Hey, this is David D. Hilster. I am David D. Hilster, and this is Dissident Science. Hey, hello, this is David D. Hilster, and I am live. I'm going to be trying to do some Skype calls. I looked up how to do some phone calls. You can do sort of phone call in, but I figure Skype may be better because you don't have to be in the United States. When you do phone calls, that pretty much is in the United States, Canada area. Been looking into that because I thought, right, I see other shows do that, and so I thought, well, let's give it a try. Maybe we can have some dialogue with some of the people who are tuning in to the live broadcast. But I want to welcome you. Tonight's subject is specifics on what's wrong with mainstream science. This again comes from something I talked about in my latest video. So if you haven't seen that latest video, go to my Dissident Science. You can go to youtube.dissidentscience.com. That will redirect you to the YouTube channel, and you will be able to see my latest video, which talks about a general overview of the problems in mainstream science, because that's one of the big things the average person on the street doesn't really know and doesn't really think about too much, and that is, why in the heck are we worried and we talk so badly about relativity and particle physics and all those things, when in reality we don't hear any of that on the regular mainstream, and certainly not from those science evangelists like Neil deGrasse Tyson, Machio Kiko. I can never get that names right. I'm sure my subscribers tuning in will help me with that. It's like every time I go and I try to say that guy's name, I'm going to have to memorize, get a picture of him, put him in my car. He looks just like Einstein, makes me look all intellectual and stuff. But I'm going to be checking here, getting on my phone and everything to see. But I am set up for Skype, and I am going to, let's see here. I think there's the number. I'm going to move this out of the way for now, but you can, if you're interested in being live with me, you can. You just look my last name, D. Hilster. Yeah, I got D. Hilster almost everywhere, because when it comes out, when anything new came out, I would register my name so I'd have it from then on. So yeah, if you're interested in maybe talking one-on-one with me, asking questions, having a conversation about something, I'll be more than happy to entertain your questions or have a conversation. So those of you who have Skype, just go ahead and you can find me with my handle, my last name. Normally my last name is small d space capital Hilster for those people who are into word origins. What country is that from? That's the good question I'll have for my subscribers tonight. What country is my last name from? In fact, my grandfather did come from that country, and I think in 1900 something, he came in, well, I'm not sure it's 1900 something, but he came in the early 1900s here to the United States from a country when he was 3 years old, and brought the name. And it was funny, not until the internet did I find any other people, any other D. Hilsters in the world, and now there are a couple dozen, I think. Well, maybe not that many. Probably a dozen people around the world with D. Hilster, D-E, small d-e space, capital Hilster. And, well, come on. This is trying to get here to find, I have to reboot my phone. But anyways, I want to thank my subscribers for coming on. And I do appreciate people's questions and comments. That's where I get a lot of my ideas. And that's where... in fact, I got the idea for tonight, which is, again, specifics on what's wrong with mainstream science. The areas that we usually concentrate on that are the areas being the Big Bang, particle physics, quantum mechanics, plate tectonics, relativity, and just basic physicality. And that's what I spoke about, of course, in my last video. So if you haven't seen that, take a look at it. That would be great. I think you'd enjoy that. It gives a summary of those things, but I'm going to talk a little bit more about that tonight. And I'm also have been working again a lot on our website, the Science Woke website. I've contacted a couple people whose books are have been around for a while. Their models have been quite a while around for quite a while. One is Stoyan Sarge. He's from Bulgaria. He lives in Toronto, Canada now. I just talked with him on the phone this past week, along with Dr. Ginsburg and Vladimir Ginsburg from Russia. He also has been working on his own model of the universe for quite a while, and I'm getting those guys and their models and their information onto our website, sciencewoke.org, so that when we're ready, we'll be able to go live with that, and that will be super cool because the idea is we want to expose people to as many of the models as we can. It turns out, in my opinion, that and this is going to be my paper, my talk for the conference. We have, what was that all about? We have a conference coming up in June of this year. It's going to be at the University of Washington in Seattle. It's going to be in a really great place, very beautiful up there. Our main speaker and one of the people we will be honoring will be Dr. Gerald Pollack, who discovered the fourth state of water. It's actually H3O2, I believe, and it actually creates a hexagon with oxygen and H2O, oxygen, and hydrogen. So I think I've shown that before, but that's quite an amazing find. And believe it or not, and I've said this before, he was sort of ridiculed and not ousted, but he was not treated well by the community. I'm not sure what community that is, the water community or the chemistry. I'm not sure, but he has been through some repression, oppression. There's lots of words for it. It's not coming to my head right now. But I'm going to try to get his story too. We have Fighting the Mainstream stories on our new website that's coming out, and I want to get his story for sure, because it's definitely the case that he has had to fight mainstream science on something that I think is so non-controversial, because it's not something he's claiming and it doesn't really happen. The water structures he's proposing, it's pretty easy to verify, but the problem is that I guess it wasn't done through the regular channels. I'm not sure, and that's one of the things I want to do, is to hopefully interview him before we get to the conference or before the website comes out. If not, I'm going to get that story up there for sure. But he's going to be honored. And then from January 26th, which is a Wednesday, through Saturday, June 26th through June 29th, Wednesday through Saturday, we'll be in a really nice room there at the university. Those people who want to go and come to our conference, it's really cheap to get in there. It's not like, $500 to get in. I think we charge $150 for non-members, $125 for members. I'm not sure, $175 for non-members. Why that happens, I'm usually awake. I'm quite well during this time of day, but anyways, which is 9:10 here Eastern time. But we'll be having that conference, and at that conference we'll have numerous people talking about numerous models. Again, that's one of the things that we do, and I want to always do, is to support other people's models. And why do we do that? Well, because right now we don't have one model that everybody's agreeing upon, and of course mainstream is not going to do anything unless they're going to in fact hey, what's going on down there, Luanda? You got to go to your room. That's my daughter singing. She's in a couple of theater. Oh, well, come and close the doors then. I'm sorry, that was my problem. That was my fault. I'm sorry. Back to physics here. Yeah, I'm sorry. No, I forgot. My fault. Anyways, thank you. the live stream, the fun of live stream. So, anyways, getting back to the conference, we have a lot of people, and I've been inviting those people to speak. Now, if you can't go, if you're not in the area, a couple of things. Again, we have dorms, and in those dorm rooms, you get a really good price. I don't know, like $45 a night. So it's not expensive. We try to make it not so expensive because we have a lot of retired gentlemen and ladies and women, and the reason we try to keep those prices and go to universities because they give really good prices on dorm rooms. You get to stay in the dorms during the summer. They're usually nice facilities. A lot of times they're pretty new. In this case, they're pretty nice and new. They also have even a meal. You can buy a meal ticket, I think, and eat at the cafeteria or whatever. And then, of course, we have all day and well into the evening activities, talks, and of course, the really great thing is to have people who are science woke like you and I, and be able to talk this way the entire time and not be worried about someone thinking you're crazy because you think something in mainstream science is wrong, or that you have this new model that no one's ever seen before. So that's something that I think is definitely worth people's attendance, because one of the things I tell people, you're not going to be anywhere, any place on earth where you're going to have people who are actually going to only talk about this for days on end, about physics and cosmology, mathematics, philosophy, all of those things, big picture, what's going on, and particular models, ether models, lattice models, structure models, what I call structure models, our particle model. So very nice. Well, hello to my subscribers. I'm finally getting online here and saying it seems like the counts oftentimes are very funny. I noticed that last time when I was doing this, I didn't refresh. I just kept it up so I can see that I'm live and everything's going well. And it turned out that the number of people actually to attend, who were actually attending, were not the number that came up. But anyways, I'm going to be talking about. I know I'm going to, if I could just talk about stuff like this. But my main focus has been in the last week or so to start really looking at the problems, real problems that people identify with mainstream science. And that's what I'm supposed to be talking about tonight. That's why I have people coming in and probably going away. Like, Dave, you're not talking about what you're supposed to. But one of the areas that I'm working on right now, my first one's going to be on the Big Bang. Now, the Big Bang is interesting because we have a guy that I also contacted. I contacted 3 people. And I've been, like I said, working on the Science Woke website, but I'm also contacting these people who are going to be at the conference, and one of them is George Coyne. And if you go to the internet and you go to look up George Coyne, you're going to be able to find, in fact, his book, which is No-Finity. It's called No-Finity Process. And again, once again, if you're interested in speaking with me, and you can get on Skype. I am up here on Skype. Skype is live, so if you do call, I can answer you. And if you want to speak with me, we can talk about something live. That is great. I'm going to give that a try. Of course, give it a try. Maybe you don't want to use it the first night, but you got to offer those things, because sometimes in marketing you have to sort of see it a number of times before you actually use it or want to use it. So I'm going to open up a browser. There may be some glitching here. So, and that's the reason, is because my computer, even though it's probably about 4 or 5 years old, and it's a pretty powerful one, it ain't so powerful for today's an age. And hopefully I'll be getting a new computer sometimes this year to make this even better. So that it doesn't glitch. So if you see some glitches, you will know why. But let me go to George Coyne. I'm going to go to Amazon.com. I'm going to look him up. Of course, I usually browse here before I show you. And George Coyne has an amazing amount. He has actually 60. You're not going to see these in here. We're working on the second edition of his book. I'm actually helping him put that into share LaTeX, because that's LaTeX is a format that you can use for publishing books. And he has, like I said, 60. He lists 60 problems with the Big Bang, and that's quite a lot. So you can imagine people who are saying, well, no, there's no problems with the Big Bang. What specific things can you say? So what I'm going to do is, first I'm going to show you the book. The second edition's coming out. I believe the first book is already not available, because I think they've sold out. Let's see here. There's George V. Coyne. Is it George V. Coyne? Is that it? Or that's another person? How many George Coynes are there? Incomprehensible universe. Well, let's put Nofinity and see if I can. George Coyne, Nofinity. We'll see what happens here. It's not finding that. That's very strange. Well, let's see if I can go to his website here. Actually, I'll go to Wikipedia, because I know I've been working on these things. I've been trying to get with each of our scientists who has been, who I'm working with to put on our website, and who has some really great things to say. In this case, the Big Bang is wrong. That's not the only thing he says, obviously, but that's one of the things. And so I've been working with him to get his information all updated and online. But it says right here, George V. Coyne, and I believe that's George S. Coyne. So let us see here. Man, I tell you, it's not easy to run all these things live. That's I think that's one of the reasons people don't do it a whole lot on their own. But yeah, the connection has timed out. All right, I'll try again. But let's wonder if I can see if I can come over here on this other computer and take a look at it. He does have his book, and I can look on his book and go there and start talking with you about those things. Again, if you're interested, you can Skype me. There's my name. You want to talk directly with me. I know a lot of people jump on during the middle of this. That's why I go on. That's why sometimes you see these go on for a couple hours, because people start jumping onto it, and the conversations, people come in and out because they are busy. Obviously, they can't always get to when I am doing this. So, well, come on. I've got a couple things going here. Let me get this login. If I can't get it and show you, I will definitely... There we go. Come on, log in and give me... There we go. George Coyne. So even though I'm not being able to get it on my main computer where I'm running the software, which you see here, which of course I got some better lighting here because my lighting was really bad, so I finally get some good lighting. I also got the camera right in front of me. It's actually right in front of my computer screen, so it's pretty cool. That gets me looking right at you, because one of the things is where, depending on how you're doing things, you want to look into the audience's eyes. Okay, so here's George Coyne. Nofinity Process. Nofinity Process is his book. I'm going to click on this. I'm going to recompile it, and I'll be able to see it. But again, if you want to look me up, chat with me, Hilster at Skype, just give me a call. I am online right now, so, and I'm not being able to do it. I think that's because I've got so many things running here. Righty. Well, that's no fun. It's supposed to be compiling. No, it's not even compiling. Let's see if I go here now. Come on. All right. Anyways, I'm not. Boy, I'm striking out all over the place. Let's see. If I go to Big Bang problems, I'm just going to go to them. And Michio Kaku, that's his name. I never forget. Michio Kaku. All right. Glenn Burker, here we go. Attraction, the idea of gravity is attraction force. Let's see. Is this the Big Bang? Am I in the right place? Big Bang is false. All right. I'm going to take a look. Cosmic, there we go. I think this is the beginning of the 60 things wrong with the Big Bang. And alrighty, I'm going to take a look at what George Coyne is saying about it. Now, again, my theme tonight is to talk about very specific things that are wrong with the Big Bang and cosmic expansion, gravitational redshift. I'm going to read some from the book here. I'm sure he's not going to mind, but I will. Come on. Wow, attraction. All right, the idea of gravitation as attractive force comes from Newton's law of universal gravitation, which states every object in the universe attracts every other object with a force directed along a line of centers to the objects that is proportional to the product of their masses and inversely proportional to the square of the separation between them. That's basically the gravitational equation, where you have force is equal to, and you put the two masses, and then you have the distance between them. And again, he's just basically describing his equation. As referred to in chapter 11 in 1718, Newton no longer believed that gravity was an attractive force. So when you're talking about the Big Bang, one of the things is, well, what it says while thinking about let me just keep reading. As referred to in the gravitational attractive force. In the text of the physics principles and problems appears the statement, the question of why objects attract each other is still not answered. No one has answered this because it is a wrong question. Now, that's what George Coyne is saying. So, the attractive force has no part in gravitation in general relativity, which contends that the results from the curvature of space-time by masses. Einstein's equivalent principle means that gravitation is the same phenomenon as inertia. This is a property of matter, resulting in stationary objects remaining as such, and moving objects maintaining their speed and direction until affected by directed by something. Einstein decided that the universe was unbounded yet finite. Big Bang theorists used this contradictory idea to support their model. Thus, the foundation of the Big Bang theory is a contradiction. Now, this is just the beginning of 60 objections and problems with the Big Bang. And George Coyne, in his book, again, No Finity Process, what's the name of the book? Where does that come from? Well, one of the things that, he is also a student of Dr. Glenn Borchert. I am also a student of Dr. Glenn Borchert, and we are students of infinity, believe in infinity in the way that Glenn Borchert had described it. And what is that? It means that the universe has infinite amount of space, and also that nothing is a final particle. You can't have the ultimate particle. That is, there are no partless parts. Every time you find something, it looks solid like it's one thing. Well, then you say, well, it's got to be made of something else. And then you look at that, and it's got to be made of something else, and all the way down, and all the way up. In fact, if you read the book Universal Cycle Theory, the Universal Cycle Theory by Stephen Putz, he authored that book with Dr. Glenn Borchert. He does talk about a superstructure where what we look at our universe is actually going around even a big, more superstructure. So Glenn Borchert, and myself, Stephen Bryant, my dad, also George Coyne, they all subscribe to infinity. So he's talking about infinity, and what's the opposite of an infinity? Well, that's the Big Bang, and that's what Glenn calls, and I don't believe he's the first one to have said this. I asked him if he actually invented the word, but he says no. It's called finity. So you have infinity, infinity. Well, finity means it's a finite thing, and that's universe. So if we read this paragraph, it says that the first objection to the Big Bang is he says that it's based on conflicting and in contradiction. It says attractive force has no part in gravitation and general relativity, which contends that it is from a curvature of space-time by masses. Einstein's equivalence principle means that gravitation is the same as inertia. This is a property of matter resulting in stationary objects remaining as such and moving objects maintaining their speed and direction until they're affected by something. So basically what he's saying is that the assumptions of the Big Bang on relativity, general relativity, which is based on this space-time concept, which is a problem in itself, and the idea of the equivalence principle where everything has to be the same, yet there are inertial frames things are moving in the inertial frames that these things are set up. As we said, Einstein decided that the universe is unbounded, that it's finite, that it's infinite, yet it is finite. And the Big Bang theorists use this contradictory idea to support their model. That is, you have a sort of an infinite universe, but it's not really infinite because it's from the Big Bang, from whatever size it was, it spreads out, and so does time and space and all those other things. And I talk about that in my video as well. So he's just saying that the foundation of the Big Bang theory is contradictory. And it comes from, again, looking at just the Newton saying, he's saying in this first paragraph here, that Newton says that, in fact, attractive force is that gravitation started out as an attractive force, but then soon after that, Newton realized that no, it's going to be a pushing force. It's a force, but the question of why objects attract each other is still unanswered. And those people who subscribe to general relativity in space-time, they said, well, now we've answered it. But it really hasn't answered it because they don't tell you what space-time is, how that works. It's just a mathematical model. In fact, the truth of the matter is, here's the one way for people who are sort of becoming science woke, who are sort of new to this to think about, is that the equations we use to calculate everything in the universe for instance, NASA has this program. I can't remember what it's called. Maybe some of my subscribers, somebody that you are right now watching this, you can tell me, maybe look it up, but there is a program that NASA has, a computer program that tries to keep of all the objects in our solar system active and up to date. They don't use space-time in that anywhere. There's just no space-time at all. They're using mostly Newton, and then they use a lot of tweaks, and they also try to do calculations between them because, of course, everything affects everything, as Glenn Borkett says in his neo-mechanical world, or his infinity universe theory. He's saying that, of course, everything affects everything, and that makes sense. The gravitational field of everything that's in the solar system affects it. One little asteroid somewhere far away from Earth will affect the Earth in some way. And when NASA's calculating those things, there's no general relativity even close. In fact, NASA and all of space exploration has been completely done without anything that has to do with anything of general relativity. The only time people say they try to see it, and actually I saw an article come out just in the last few days that says, we find Einstein crosses. What is an Einstein cross? Well, you have an object that's supposedly very dense, has a huge gravitational field somewhere in the universe, and you can see the light bending around it, and so you can see an object that's behind it, or you see a curvature of where it's supposed to be, and it's not exactly where it's supposed to be. But that, of course, we also know by the Dr. Edward Dowdy from NASA, a retired NASA scientist, that he in fact says that the reason light bends in space is because it's going through some mass, either a corona of the sun or space dust or stuff, space stuff out there. And what we're really seeing is the bending of light because it's going through something, like water. When you see a stick, you put a stick in the water, you see it bend. You see that it looks like the bottom is way closer than it is. And we all know this just by if you've ever been to the ocean, or that you can see to the bottom, or to a pool, and you stick a stick in it, or your finger or your hand, it looks like it bends. Well, yeah, light is bending. But what's bending light isn't gravity or space-time. It's other stuff, and in this case, atoms. So you have this whole idea that when you have with gravity, when you look at general relativity versus Newtonian gravity, this whole idea that if you have this very complicated space-time that somehow is supposed to give us more information, and the idea was, oh, it bends light. Well, now we know that when you look outside the corona of a sun, our sun, and you see a star, Dr. Edward Dowdy, who spent his life with laser optics and working with this kind of stuff, he says, look, you don't see that. What you see bending, but only when it's inside the corona. So the whole idea that the prediction of general relativity, that light is bent by gravity, is sort of shown wrong, because it should be bending where it's not bending it. And so that's wrong. So what you have is a mathematics that's way more complicated. So complicated that, yes, Einstein needed help. He was a good mathematician. Some people say he wasn't. He was pretty good at mathematics. So he had some people help him work out with the general relativity equations. But no one uses them. No one uses them. The gravity, only when they are looking, they say when they're looking for planets, and we're going to use the gravitational lensing for something. But most of the time they're looking for planets, they're seeing the dimming of a star by something that passes in front of it, the wobbling of the star because of gravity and regular gravity. Again, they're not, they say they use the general relativity, they use it very little, if at all. So if you are new to the idea of being science woke, and you're saying, okay, well, is general relativity, but I thought it was all proven and all that. Well, the truth of the matter is it's Newton's equations are much simpler. Those are the ones we use, and that seems very strange when we're told all the time that relativity, without relativity, the whole universe wouldn't work. That's the opinion of big science, big physics, big cosmology, and not everybody in physics. And the truth of the matter is there are a lot of physics. In fact, I will tell you a secret. The majority of physicists do not subscribe to particle physics, the modern theories of particle physics. They don't necessarily even subscribe to relativity. So we have to be very careful. There are just the voices out there, just like in the rich and powerful in other areas of human activity in life right now, have a bigger bullhorn, and they say things and they have more power. Yes, the people in the universities will say this, but believe it or not, I have heard from many a person, because of me being in the area of being outside of mainstream, that they actually, I remember one teacher, now either read this story or it was a student reporting this, that the teacher says, I'm going to teach you quantum mechanics right now, but all these conclusions from it, I do not subscribe to them. So that's pretty bad when you have people who are teaching physics saying they don't subscribe to it. So anyways, this is all under George Coyne's book. I'm trying to get to his information. I'm not being very successful at that right now, and I apologize because I'm running Skype for those people who would like to Skype and talk with me. You can do so. I'm sure that most people there's like, I don't want to talk with them, but I'd be very happy to converse. I am very easy. I'm not a person that's going to get mad at somebody because they have a crazy idea that people think is a crazy idea. I'm not judgmental on those things. So if you have something and you want to discuss it, or you have your own theory, you wanted to talk about it, I will be brutal. I won't say, there will be no personal attacks, but I will certainly talk, if you're saying, well, I sort of, understand space-time and the bending and all that. Well, you can say you understand it. You can say you understand it according to the way big physics talks about it. But the question is, do you understand the big problems that we have, for instance, like with space-time and all that? Okay, wiki at naturalphilosophy.org doesn't want to come up. Nothing wants to come up on my computer here while I am running Skype. So right now, no one's taken that. Aristotle may be right in his theory of impetus. If there's a flow of stuff going through and around ordinary matter, constant terminal velocity in fluid space. Wiki theory of impetus. Yeah, I'm pretty familiar with with those ideas. In fact, inertia is something that's talked a lot about, even with my dad and I and our particle model. You know, inertia, to us, gravity is caused by random particles moving, particles that are similar particles moving in random directions, and it causes a pressure difference. Whereas electricity and magnetism and all that are particles that flow together. Now, that can be at any level in the universe, so, and I've talked about that. But in that, the idea of what you're saying is this, these flows and the pressure and all those things, it all comes down to what model you're subscribing to. And of course, the problem with us is we don't have a model. And the problem with us is, besides not even having a model, in our most models, they don't even talk about or even get close to giving us a model of what light is or what gravity is. So again, I think this is where we're coming back to this idea, well, we're trying to unify the forces of physics, but the unification of the forces of physics are from equations like the gravitational equations, Coulomb's law equation, which looks very similar. We have the nuclear strong force, the nuclear weak force, all of those things. We've been working in parts of the universe and making empirical equations, that is, equations that work to describe what's going on, but not necessarily tells us what the actual stuff is made out of. And because that, we've created this artificial idea that we have to make all these equations then come together, and then we get one idea in who does that the best. There's nobody who has done that better than Dr. Bill Lucas. If you have not gotten his book, this is the book, Universal Force, Volume 1. And in this, he has the force equations, which are quite complicated, but he has indeed succeeded in bringing all the forces together. And he also proposes structure. Here's a structure of a toroid structure that he looks at quite often and has in his books. He talks about how that is repeated at all the different levels, and then he does have his force equations, and they're quite amazing, but they're all based on empirical equations. Now here's a model for the atom, for neon, that he's looking at, and you can see that they are toroids, and again. What people are trying to do today, because of the problems that we have, these specific problems we found in the Big Bang and general relativity, all of these things, what we're trying to do today is actually come up with what is the physicality of everything. And one of the problems we have in science is the physicality in everything. And because we don't have the answer to that, we get lost and start thinking about really ridiculous kinds of scenarios, because when we shoot what we say is a photon or one electron, and we call that light, and then we said we're going to shoot them individually, but it acts like a wave, can particles. The reason all of that has problems is because we do not come up with at all. We have no model of the universe whatsoever, and the physical model of the universe. So that's just something that is lacking completely in physics today, big cosmology. And I can't get to our sites. Maybe our sites are having problems. We did have problems with our site. We actually have been hacked numbers of times because I think of our database with all the information we have that is going against mainstream science. We actually, I do know what country they are from because they announced themselves as that. So hey Pyro, how you doing? Dave, what is your explanation for why the water molecule is V-shaped? Oh, I do have an answer to that actually. But our websites seem to be down again. I'll check with our provider. We were having some problems the other day as well. Wonder if Science Woke is also there. Are we starting to be attacked by the powers that be? I don't know. I'm not into conspiracy of those things, but it's very strange. Let's see if I check another server here. Nope, that's okay. Oh wow, establishing database connection. Well, our host has been having problems. So, anyways, the question is why is the water molecule V-shaped? And actually, the answer depends on what model you're looking at. Now, if you're looking at a model like this, so the answer is Pyro 314, PyroPy. If you have if you're looking at, for instance, this is the search effect or radiation pattern for a charge or motion. This guy, Dr. Lucas, has, you want to see some equations. This is what happens when you actually start looking at combining the empirical equations into one equation. They get to be pretty complex. And again, just think of taking all the equations that we have that are sort of that look at pieces of the universe and then trying to make them all into one big equation. But the answer to your question, I will tell you in two ways. The general answer is what model do you subscribe to? So if we were to have a model of the universe and we were to say, okay, let's look at today's model of the way atomic structure works. And we have atoms made of protons, neutrons, and electrons. They have charge, and those charges affect how attractive they are and how repulsive they are. But those are, again, empirical equations, and what we then try to do to find out what those angles are is to then surmise by we know that oxygen has eight protons, neutrons. Neutrons are up for debate, even mainstream right now, but at least 8 particles in the middle in the nucleus, and then electrons on the outside. And when they combine with another they have shells, SPDF shells. I'm not saying this is the way it works. This is what you have for mainstream science. And those shells and their configurations and how many are there should help give us an idea of how to get those angles. But if you look at a real physical model, that's an empirical model. The empirical model does not have, unfortunately, it does not give us exactly how these things are going. They give us the best we can do in the mainstream is to tell you a probability of where an electron could be. That's the best we can do. And from those we try to get these angles. Now I'll tell you, we don't do a great job, because when you get to computer programs that try to simulate the way molecules are put together, the way that they do that and the way that they deal with that is that they use sort of tweaks. The same thing they do, they use equations. They have a general model, and that model is an empirical model. What does that mean, empirical model? It means that it doesn't have to do with the physicality. It's a convenient way for them to position things in three-dimensional space, and when they put oxygen together with 2 hydrogens, and their model should come up the way it should be with that angle, whatever angle that is. And then what happens is when you put that together with other molecules and other atoms within their computer program, and I haven't used them, I don't know what the names of them are, but if you are let's say, an organic chemist, and your job is to try to come up with new molecules to see what's going on, they will test them to see where they are. Then they will tweak their empirical model inside their computer to try to get those angles. Now, that's not answering your question still, Pyro. The answer to your question is, yeah, okay, I'm going to give you our model because it's a model I understand and I think can easily give someone an intuitive way of why angles happen and what makes atoms stick together, what makes molecules stick together in the way they do. Well, in our model, the way things work, our model has basically two things in the universe. You have random particles that are the same that go in all kinds of directions, and then you get gravitational fields. What does that allow things to do to orbit? So you have for the sun to, the Earth to go around the sun, you need to have gravitational particles. It turns out that you can use the same particle for light and gravity, but regardless, those particles in randomness, just like air pressure, you have random, sort of flowing around right now here, and those are waves through it. That's what we call gravity. So for an electron, or whatever that's called, to go around a nucleus at a smaller level, there's a much faster particle, much smaller particle below that keeps that electron in orbit. We don't have this thing where we put a plus sign with our pen onto the nucleus. We say, oh, this is a proton plus, ta-da, and now this is the electron, and I'm going to put a minus sign on it, and they magically attract. We don't have that. So in our model, what we say, if it's orbiting, it's being caused by a field of like particles that are traveling around, and those like particles at this level is the G1 level, the G2 level, and so that's what's going. So the second thing the universe has at all everywhere, there's actually three different ways particles act. The second way is that they flow together. They flow together. Electricity is a good example. We say it's the same particle as gravity. It flows together. So you have atomic structure where you have the G1s being guided by the nucleons. Now, the way I would say it works, so you would have the ability for now, instead of the particles flying in all different directions, now they are directing and flowing. Those things, what we observe, those are in our model. This is my model. This is my dad's model. And I'm only giving you an answer because in my mind, in my way, the only way I can answer that question truthfully, truthfully, as best as we can, is to really have a model that tells you exactly a physical way that you can interpret it. Is this right? No. Is this wrong? No. It's a model, okay? And so the model, in our model, what you have are flowing particles. Flowing particles. We're rewriting our book to talk about this model in the exact same way. So what do you have? You have a particle like an electron going around a nucleus, which we call a proton. It's not charges in a model. That's magic. You can't have magic. So what we have, we have a G2 particles. We have a gravitational, little, really small, really much faster, way faster than the speed of light, going and keeping that in orbit around the, just like a planet. And of course, it can be in all kinds of ways. And we say that there's more than one. There's if you have like a hydrogen atom, you don't have just one nucleus and one orbiting thing. There's some actually evidence for that. What we call an electron never is an electron by itself. Oh no, Dave, we know. Well, go and read up. Just go look up electrons. Start reading about it. What you find it's a stream of stuff. And then when people say it's a stream of stuff, it must be a particle. And there's some. Yes, that's true. But what with the electron? So here's the oxygen. Oxygen has 8 of these suns. Let's just say sun. Most of the solar systems that around the universe that we can see, a majority of them have 2 or more. Not one. We're a hydrogen atom, or we're a barium atom maybe. But anyways, the sun. So you have 8 for an oxygen. You have 8 of these nuclei, and so you have a lot of stuff going around it. And it's got a format. We don't know. Our model, we haven't hacked into that level. My dad's starting to do that, and it's kind of scary, but I don't talk about that. But basically, you have something going around that. And what that sets up flows. Even if it were just one electron, just like, let's say it's the standard model. The way I would say it, and what we call polarity of atoms. Why does a hydrogen sit here and then an oxygen sit here and then two hydrogen atoms in this configuration? It's because the flows. When you have flows of particles, they flow together or they flow around something. There's a flow there. So if this is, let's say this is an atom, and what you're seeing on the surface here is the result of flowing particles. So this is not, of course, we know there's mostly space here, but let's say this is an atom and there's a nucleus in there and there's flows around there. So that flow causes attraction and repulsion. So if you look at the Denew effect, that is, you look at the Yonel Denew and you look at his underwater experiments, you will find that when you have flows that go together, that causes any bodies that the flows are going around to attract. Now you can figure out the mechanics of that in our model, why that is. It's called the Denew effect. If those things go in opposite directions and they actually hit, so they're going around and they're hitting. See my fingers? They're hitting like that. That causes repulsion. So you have an oxygen atom, and you have stuff flowing around it. Stuff's orbiting it. It's orbiting it. Now, you know what that orbit is. I'm not saying that it's an orbit that's a perfect sphere. It's going to be non-regular. It's going to actually lose stuff and gain stuff. It's not going to be, every time you add a nucleus, you don't get an exact 27 G1 particles for every nucleon you have. And so if you have two, you have double that. No, it's a capacity, and that capacity, because no particles are identical, are going to be different. So in general, what you do is you have the flow that's going around the nucleons, the nucleus of an oxygen atom. You have flows going around hydrogen, and when they get close to each other, just think of suns. And you have suns, you have one sun, and then 8 suns, and you have lots of comets going around them, flowing around them, because that's the way atomic structure works. It's not like our solar system necessarily, but it's going around, and they're going around, of course, fast or slow, it doesn't matter, it just depends on how fast you're the time. Those flows, like the Denew effect, will cause attractions and repulsions. In someday, my prediction is, because using our model, and I'm not saying our model's right, but our model predicts that once we understand those flows, and that we know that the only reason things orbit at all is they're in another field which is smaller, one level down, and those things orbit, well, what happens then is we can then calculate for sure, using real models in a computer, of how and why exactly the oxygen atom and the two hydrogens form this V. Right now, it's all empirical. Right now, we see what it is. We have a model of protons and electrons. We have shells for those orbitals. There is some evidence that maybe it's, there's some, I'm not saying that there isn't good evidence or good data out there in mainstream for atomic structure, in the sense of, at least when you're talking about atoms, and they're trying to describe it with a nucleon and a orbiting piece, what's going on. I'm saying to you that the flow of these particles, to us, they're all going at the speed of c, so gravity and light and electrons and electricity and magnetism are all just the flow. It's the gravity is random directions, like a gas, just all random directions going all around. And then you have flows. The flows around atoms set up Denew effects, which have different attractions and repulsions. It's going to find an equilibrium. Those flows, just like when you have in water flows together, that causes those two rotating objects in the baby pool of Yonel Denew, which again, I will tell you, if you look up Yonel Denew and look at his his water experiments and underwater experiments, they show us and give us a physical model for why flowing particles causes attraction, repulsion, and guess what? Throwaway charge, throwaway polarity in atoms. That's where it comes from. Oxygen atom flows around it. I'm not saying what those flows are. I don't know. I didn't hack the atom. People are looking at the configuration, perhaps, of what the nucleus really looks like. We say there are 8 somethings there, but what are they? Are stuck together? Are they in a tetrahedron? Are they touching each other? Are they orbiting each other? Are they actually just a bunch of the same electrons in the middle? We don't know yet. So that's the way I would talk about it. My guess, electrons are vortices energized by photons trapped between shells. Electrons are vortices. Okay, so you're saying you believe in an ether, Illuminati, I guess. I'm not sure. So what you're saying is you're saying electrons are vortices energized by photons trapped between shells. Wow. I mean, I'm a real good visual person. I'm actually an artist and can draw and do all that stuff and paint and draw your portrait and all that. So I'm very visual, but that's getting complicated. So, I don't know. Anyways, okay. Electron vortex beam. Again, I don't have any problem with anybody's theories. Jeff Yee, I love his theory, and it's an ether theory. But his flow, everything he talks about has some physicality. He doesn't. There are some things in it that he doesn't explain. He doesn't talk about infinity, for instance, in his, and that's okay. I don't have a problem with that. But anytime we talk about electrons and vortices and energized by, we have, in my opinion, and it says trapped between shells. What shells? Egg shells? What shells? I mean, we talk about shells that are there, but one of the problems when we use our vocabulary, and this is the case, that's why I'm your science therapist. You know, I look at this and I go, well, that's nice. You have magical shells. Why are they there? Tell me why. That's why I don't tell you that there are shells in atoms unless, of course, we have really, really great proof for that. And then we have to explain why that is. But you have to give an explanation for why those things are. I mean, I understand it because right now there would be no different, in my opinion, those kind talking that way when you talk about electrons are vortices. That's a little bit more modern. Because it's vortices and what, again, vortices in ether. And if you do, what's that ether? How does it work with the rest of the universe? And energized by, is that colliding with? Is that waves in? And trapped between shells. Okay, what shells? Why are they there? So the moment you hook your wagon to the shells in mainstream science, which is perfectly fine. I'm not saying you shouldn't or that they don't exist. I'm the first to say that there's a lot of evidence for the way these things flow. You still are going to have to come up with a way, why they are there. You know, and if you don't have a model that can at least accommodate you hacking that in that model, then I'm going to say you're just basically another empirical way of looking at things. You're not giving us a reason. Why do they curve around? That's one of the things about our model. If something goes in a circle, we know why. There's something below it doing that, and it's going to be, and that, below it, and below it, and below it. Yes, you don't have to tell us all the levels of the universe. That's ridiculous. We can't. None of us can. But you have to be very careful when you use those things. This is terrible. Tried 4 different browsers now. My bandwidth is fine, but YouTube is blocking viewing of this stream. Oh, wow. How does it form a bond? Explain magnetic attraction. Well, magnetic attraction, I don't know what's happening here. If people are, I don't know, why would they block? They don't block me. It makes no sense. I'm not doing anything that people are going to be blocking me for, I don't believe. Let me see if I can get to YouTube on here. Probably can. There we go. And come on. And then I'll show you the underwater experiments. So this is the answering the question to Hilster. What is magnetic attraction? There's two ways we can answer it. One is that, in fact, magnetic attraction comes from what I call the Denew effect, which is a flow of particles. Magnetic attraction is flowing particles together either in a loop or at least flowing together like this. Or, so here you have a flow. Here's a flow. Let's just call it a loop because it's easier to talk about. So you have a magnet or a battery, which both have flows of particles around them in our model. So you have, if you can actually measure around a battery, the magnetic field around a battery. It's just, the battery's holding electrons in the chemical form, but it holds, believe it or not, electrons or G1 particles. It's holding those orbiting things around it. And that's a flow. So when you have this battery, there's a flow to it. It's a little bit more complex than a magnet, but a magnet has a flow. I thought I had some magnets down here. Shoot, I've got to get those available and have those ready with me. Oh, here's a magnet, but it's totally the wrong magnet. This is one of those magnets that stick on. But if this were a magnet and there was a positive and negative, it'd be flowing like this. There's a flow here. So they're going in a direction. That's why you have north and south on a magnet. This is our particle model, for instance. But even if you are an etherist, etherists say the same thing if they go to Yonel Denew. So I'm going to go to the Denew effect. I don't think, no. Oh, there we go. Woohoo! I got to it. Why are they letting me go into YouTube, but they won't let me go into other things? That's weird. Our seem to be down. So I'm going to go to Yonel Denew, and I'm going to show you this since no one's Skyping me, but we can always discuss if you want. Let's see, unraveling the nature of radio waves. Let me put his videos here. Okay, there we go. This is his very famous video that got me started, and I think it was in 2010. We're going to take a look at this. There we go. What you see here is a baby pool. I'm explaining to you what a magnetic attraction is. This is the, in my opinion, probably some of the most important findings in our lifetimes in this 100 years, experimental wise. So basically what does he have? He has two tubes, two things in the water that make water flow around the two cylinders. And what's happening is if they are traveling together, if they travel in the same directions, they will, you notice he's pushing on them and they're repulsing, okay? You notice that? He's pushing it toward the one there and it'll go against, you see how it's going away from each other? That's because they're going in the same direction. When they go in opposite directions, they attract. So he's going to be showing that. So he's stopping them. Again, this is water in a pool. Those are discs. Those are wooden discs. He has tubes there, and they're going around. Let's go and do that again. Let's see. There we go. He's talking about it. Let's see if we can have him talk about this.
Here we have two identical cylinders completely submerged in water and connected by two flexible hoses to two identical electric motors. The electric motors will be driven by a common 12 volts car battery. In one case, the motors will rotate in opposite directions, therefore the cylinders will rotate in opposite directions in water. In another case, the motors will rotate in the same directions.
This way I can hear it
Therefore,
not
the
interfere
cylinders will
with
rotate in the same
getting
directions
echo.
in water.
Okay, so he's explained what it is.
We're going to start the motors, which are going to rotate the cylinders in opposite directions. Let's see what happens. We start the motors now.
Okay, so they're spinning in opposite directions. Now what happens?
We see that the cylinders attract
There
each
you
other
go.
now are sticking to
Attraction.
each other. Let's try to separate.
Just because of one thing. particle flow. The water around those cylinders are moving in together. It's not random flow. The water is sitting there in random motion right now, but he is causing not random motion, but flowing motion in random particles.
And sticking to each other. Let's stop the motors.
Now he's going to stop them.
We observe that the cylinders are coming back to their original positions. And now let's start the motors again.
And there he goes. Now they're in opposite directions. I mean, they're in the same direction.
They attract each other again and...
Oh, no. Okay, opposite.
Each other now.
Okay,
Stop
opposite.
Now.
Opposite. I'm sorry. He did the same thing. He did it twice.
Conclude that cylinders rotating in
Sorry
opposite
about that.
directions, submerged in water, attract each other.
Opposite flows attract each other. That's why negative, that's why south and north poles of magnets attract.
And see what happens. Let's start the motors now.
Folks, this is, in my opinion, this is about as close as you can get to proof of what it is. Now it's in the same direction.
We observe that the cylinders repel each other. Their relative distance is increasing.
Yeah.
Let's try to push them against each other and see if we can reduce the distance. And what happens if we reduce the distance?
So you see, it's actually moving away. And that's why he has them on those plastic poles.
There is a force which is acting so that they repel each other. This force is obvious.
So there you go. There's your answer. Let's see. I'm sorry. Explain magnetic attraction. So Hilster, there's your answer. I call it the Deneau effect. It's in our book that we're rewriting for the 14th time. We've broken it down. In fact, part of our book, we're going to make it, we're going to have a physics textbook that's basically going to just pretend and teach like the particle model is real, and we're going to just set up the way everything works. And the Deneau effect is in here. And it turns out that the Deneau effect, I'm going to tell you some of the answers to our book because we're going to be teaching it. Oh, by the way, just going back, there is H302. This is, if please consider coming to our conference at the University of Washington. The man who discovered this is in our book as well. And I talk about exactly why these things would set up in the way they do, again, because of the Deneau effect. This is the fourth phase of water. We have water as a liquid, as a gas, as a frozen solid, and this is called easy water, and they form sheets. This is why you can balance and put a coin on top of a water. I'm sorry to get off track, but it's just open up my book. And basically, this is what this gentleman found. It is incredible. If you haven't read his book, The Fourth Phase of Water, get it. I absolutely recommend it. And I just happened to put on that page, which is in our book. But I'm trying to get to the Deneau effect. You can see that we're looking at the flows. And you noticed here that you see on the screen there, you have repulsion going on because of, and you have repulsion and attraction. I think that's actually labeled wrong. But on the other side, you see a battery and a circuit. It also has flows, and we have reasons to believe that. And my father is actually doing an experiment with resistors that are looking into that. Oh, and here is a picture. Again, these are illustrations that exist nowhere. They now exist while you're seeing this because it's in my book, in my dad and I's book. This is Conceptual World of Atomic Bonds and Polarity. And you see there that those are orbitals that are described. and they have flows to them, and those orbital flows will cause things just like the Deneu effect to keep those together. And why do they stick together so forcefully? There's two reasons. One is that they're held together by the same force that holds nucleus together, which is called the strong nuclear force, and that strong nuclear force is what in our model does the same thing. So that's pretty interesting. Planets has atmospheres which have hurricanes, tornadoes, and other types of vortices. Atoms have vortices orbiting around them as well, and flow types is my guess. I got you. All right. Yeah, it could be. I agree. I see you, Illuminati. You're starting to see our model a little bit. I'm not saying it was right or wrong, but yeah, there's flows. You saw in. Oh, I was supposed to show you the Deneu effect. Come on. Wow, we really got to get our book done. There's just so much good stuff in here. Explaining why their color, and this all has. Where's the Deneu effect? Alrighty. Oh, here it is. Of course, it's on page 6. Okay, so there you have two, like the Deneu effect. So you have two masses with flowing smaller particles going around them, and I actually wrote computer program in HTML5 to actually come up with the random particles that are distributed around there with little tails that gives you the direction. So that's just a way to do it. Again, I had to come up with this. Nobody's modeling this, so that's attraction. And the reason that happens, believe it or not, is because those are stable flows, so there's more mass, and then those nucleons, those nucleuses can come together. It doesn't even have to be nucleuses. These can be galaxies. It doesn't matter what level you're doing it. Now, when you have the Deneu effect, when they are coming at each other, then there's interference. Those things hit, and that causes those things to scatter, so that the amount of particles that are between those two things, because of their nature, is less, and therefore that the gravitational field between those, because all these things orbit because of gravitational field. Now, if these are atoms, that's what we call G2. There are particles that are going way faster than speed, or way smaller than the electron, and all those other things that cause this to happen. So this effect is happening again. It's interesting because the Deneu effect in this right here, in this video, is a little different from the Deneu effect that really happens with pure particles that aren't in a medium. What you have here is water, and there's another thing that happens. Water is being affected and pushed down by gravity. So you have a little bit of difference going on, but even with that difference, it still manifests itself into forming. And the trick is, it took us a long time. It took us, we're now in 15, 16, we're now coming up to our 15, 16, 17, 18, 19, our 4th year of this model. It took us probably 2 years to hack why is it the flowing particles and the G2 forces, the forces below, are doing that. Again, if you want to not get mixed up, think of atoms as being solar systems, okay? And I think of electrons as being comets, not Earth or Jupiter or anything like that, but comets. I look at more of planets and stars as more like nucleons because they're bigger. But think of the small lots and lots of the small asteroids that go around something, for instance. Well, that's the way I sort of look at it. And so you can look at, for instance, how do you get those flowing all together? Well, you can set up a bunch of suns in a way that if I shot a comet through it, it would sort of zigzag its way, and that's why light bends. Well, light are particles and flows of particles and comes in waves of particles. Well, the reason water bends light is because those G1 particles, just like in a maze of suns that are sort of in regular position, it's not going to travel a straight line. So it's not going, you will not measure C as from point A to point B because it's going in a non-straight line. So that's one of the other things. Let's see here. The next Nobelist is here. Yeah, well, I think, his work, I think you're probably talking about Lionel Denis. Yeah, he's on our website, which we can't get to for some reason. The InMotions is our host for both of those. Seems to be problematic right now. But he is he's working on a theory that he calls a simplistic or a rudimentary ether. He also talks about toroids and, of course, smoke rings. This is a common thing. This is him. I'm going to mute this, but this is a common thing. Who has this also? Toroids show up in Bill Lucas. Toroids show up with James Carter. Toroids show up in a lot of people's models. And he's just showing that, that's a stable configuration. Then why can't atoms be made of toroids, that is flowing particles? That's basically air, right? And those things are air going around in a toroid, and they stay quite stable for quite a while. Of course, they're traveling. Again, we have a little difference that you can. There you go. Again, it's underwater. Now, this of course is also within a gravitational field. So, but he's saying that in ether, you have ether, and instead of like a standing wave, which is Jeff Yee's idea of what a mass is, Lionel Denis is saying, well, we know what magnetism is. It's the flow of ether flowing around something. And then, of course, we has also stability of vortexes. And how does that play a role? Is that actually building things in the universe? This all comes from, though, I want to tell you, because I'm very pedantic, and that is, this is one of the ideas that ether is going to describe everything. Now, as you know, if you've been a follower of mine, that in fact, I will tell you that, and I think it's very true, I'm sort of a big picture person. I try to look at the big picture. I will say to you, and I think this is pretty much a fact, ether was made on purpose to describe waves. That's the idea, was to describe light. The concept of ether was invented, and I'm talking about ether specifically as particles that have light going through them as waves. That concept absolutely comes from the idea of, I want to describe what light is. And then from that, people have tried to then infuse into it gravity, infuse into it the stability of particles, all of that. And then they try to make ether the bottom level for everything upon which everything is built. But of course, a better model for that, in my opinion, is the ether model for Glenn Borkert, who says you have infinite model. You have ether at all kinds of levels. Where he has ether at all kinds of levels, we have in our particle model gravitational at all levels. And our light is just particles in movement. The only difference between gravity and light is that light moves in waves of particles. So light in our model is the shower turned on shower massage, where you can get a frequency. Your shower massage gives you a frequency of that, and they're all particles. There is no wave through anything. Those are particles, and that's what my dad came up with, the solution to wave-particle duality. That was his solution, at least. And but ether is the idea that's all standing sort of around. They're not moving. It's not like our gravity particles, which are moving in all directions. Ether sort of sits around, and then when they stay around, you have waves, just like we have all the atmosphere right in front of me, oxygen, carbon dioxide, water, all kinds of molecules here. And when I talk, they hit each other. Those things create a wave. Those waves can then be detected by my ear or by the microphone right over here. This microphone right there that I'm pointing to, and that goes through. Then it changes that to electrical pulses, which is digital, by the way, which is exactly the same as our model, etc. Blah blah blah, and that gets to you. But again, this idea here, what he's showing you right there, is that yes, you have stable toroids in a gaseous thing, and he says that's what ether is. But I contend really ether came from the idea, let's solve the problem of light, and then let's try to fit gravity into it. Phonons, sound, not photons. Hey, yeah, phonons. Okay. So that's a vortex is in fluid vortex. Vortex as in fluid vortex. Well, I'm not sure what that's meant. Let's see. Shell, fluid boundary layer. Could be. Again, what you need to do is put together your model and put it in a book, like us, which never comes out. But because we have learned how do you teach a whole model? You got to know all. Like the problem with when we started writing our book is we didn't know where to start. And finally, when I figured out that the universe is just basically random particles flowing going in all directions that are similar, or flowing particles, or particles that come in waves that in fact, then I could start actually coming to being able to explain it. But anyways, that's good enough. You write a book, write about how you think it's there, and you can explain it. So, let's see. Global information within the universe. Okay. Huxter, it says, particles are information fields. Particles information fields. The way I would look at it is maybe a little different. This is when we were working on the particle model, and I was trying to figure out, why do you have light? Why does really light? Why do we have our eyes? Why does that exist? And the reason it exists is because when you shoot waves at things and you have waves, information will come at you. That is, blue gives you a different information than if it was red. And when you get all the colors, then you can get the information and make a map out in space to see what kind of thing you're looking at. So the way I would put it is that information is particles in waves that come at you in waves. Information comes at you. The only way you can get information is waves. That's why in gravity, in a gravitational field, you don't get information. It's just the field that sort of pushes things together. Anytime you want any information and it's going to be useful, is like light. That's why we have eyes. That's why we have ears, because those things are transmitting information, but it's in digital form. Everything is well, that's according to our model. It's just waves of stuff. You have to have a frequency. The only way you can have frequency and information is you have to have sort of similar particles coming at you in waves that will tell you a frequency, and that frequency will be translated in something that's going to be useful. And that happens with our eyes and our eyesight. That's why, and then we can, in our brains, create all this stuff, this imagine of where the world. Yes. So, I don't see I guess if you say particles as a plural, but in they coming in waves of particles with frequency, that will give you information, and that information can impart something. Now, if you have a particle itself, particles, I think that's just too general. It doesn't, information really comes in. That's why when we look to try to see what's below the earth, and when I was in Brazil teaching English to a person when I was living there, he was a geologist, and they would set off explosions on the earth on the surface, and that explosion would be in waves, and then those waves would hit stuff and it would bounce back. So they would send a wave of information, and that wave of information, which takes time to travel, would hit something, and then it would bounce back, and it would bounce back at different times in different ways. Then they could reconstruct the layers underneath. What was it? They were sending waves of stuff. So they weren't sending. Obviously you can't shoot something through the earth, so it ends up being a wave. So they hit this thing, that causes a wave to travel, and that wave then reflects and comes back. Well, that's what I'm saying. Information comes in waves, and waves have to be plurality of particles. That's why I say in one of my videos coming up, I should do it, I gotta do it, is photons. Photon doesn't exist, because anything can be a wave, doesn't matter what it is. So you can have a wave of asteroids coming at us. So someone sends us Morse code with asteroids, it's information. So, but waves can't happen without more than one. So the idea that you have a photon is, excuse my language, a dumb idea. So a photon is a stupid idea, that a particle is wave. No, waves have to have more than one thing. Okay. Particles a wave. Information is a concept. Yeah. Info to give form to the mind, putting concept in your brain. Yeah. I mean the global information within the universe. Global information within the universe equals a globe map. I'm not sure. I think one of the things that I stay away from more than other people, and I know Illuminati, you use a lot of vocabulary, and there's no... Listen, the world is a free thinking place. Everyone has the right to do that and use the vocabulary they want. But I've found that I shy away from vocabulary and only use it to describe something physical. That is, the physicality has to come first. And I think you are saying that, but a lot of times there's a lot of loaded, I've talked to you about this before, there's a lot of loaded information of the words people use. And when I look at those words, I really try to reconstruct what that person is really talking about. And in my, oftentimes I find it's loaded with the words. And I go, what's this word? What's this mean? Wait a minute, you're using this. And a person has to walk back. And I think that's one of the things you have to be careful about with models or with your understanding of the universe. What you end up is with instead of empirical formulas, hey, I just made up a word, empirical words. So empirical words, well, they're all empirical in some sense, but empirical words are those words that are full of all kinds of stuff that don't give you necessarily a clue of the physicality. But I know, Illuminati, you do have that. The problem is oftentimes when I read these things like, a globe map, my goodness, and I think if we spend all our time explaining, I'd rather have time explaining what it is and then hanging the words off of that than having the words and then having to explain what that means. I think that's one of the things that my father and I just don't do. You don't hear my father and I talking about, some mega idea. We're mostly talking about particles in motion and what those are. And we try to keep everything to that kind of level. We can because of our particle model. Yeah. That's okay. I'm just saying, my goodness, globe map. Whoa. Those are loaded words. Information fields are mathematical maps. Wow. It'd take me a while to untangle these things. Again, those words are really quite loaded. Ether is false, space time is real. Matt Riccio. Ether is false, space-time is real. Photons. Sorry, man, the false motion is a resultant if space and time. I can show you the math and you will no longer be misled. Okay. You can shoot neutrinos. Oh, this guy knows the stuff I've been talking about because he is... Well, call me and Skype. We'll talk about this because I'll go for it. I will talk to you, but you're here to save me. I can say, I would imagine. Space-time is a mathematical construct. Period. End of story. I mean, even Einstein said that. So to give it any kind of physicality or to say that it's a physicality, it's just another way to describe why bodies in space orbit each other. A mathematical, empirical model. It's not a physical model. To say that ether isn't real and that space-time is, no. Ether will give a physical model. Now, if you have a ether that has gravity with it, which is ether around mass is thicker, then you have some physicality. Then you can give to something that can describe the same thing as space-time. But space-time has no physicality. Even Einstein, its author, says that. Now, what we do is we start trying in modern physics to start saying things like quantum soup, the fabric of space-time, yet we never say what that is. Mathematically, you can tell me empirically that it's mathematically all day long. I can understand it, and I can even do the calculations. I have a bachelor's degree in advanced calculus. I like math. Math is a wonderful system, even though a real number system has a lot of problems, like square root of -1. But just saying that the math shows you, we can show you this, there are big problems with it. And the biggest problem that the mathematics of general relativity has is that you have to answer the question that the NASA scientist Dr. Edward Dowdy says, well, here's where gravitation is supposed to bend light outside of the corona of suns, yet it doesn't bend. So then you have the problem of how do you explain the contradictions even to the prediction that light is being bent by gravity. So we're not talking about small tweaks or problems or me understanding math. You have to explain why it is that general relativity predicts that outside of the corona of a sun there's still some bending that should go on, and it doesn't happen. So basically, Einstein said it. 1,000 pieces of data can support my theory, and one can disprove it and show it's wrong. So space-time and the neutrino, unless you read Karazani's work and you can give a counter argument to what he found, why you just... It's not our words are not magic. Our words, because we say the neutrino can be this, and yeah, we have this, and we saw them. Even the evidence from supernova in 1987 that supposedly showed neutrino detectors detecting neutrinos from a burst. There are so many problems with that data. There are so many problems with that data that claims that those are neutrinos. And also the neutrino detectors. They're detecting stuff. Yeah, they're detecting false hits, which they try to avoid vehemently. It's on and on. So it's not, this is what happens. This is the arguments you get from mainstream. You have people come in who learn the empirical equations for what's going on. They state things like, I'll give you they state, GPS uses relativity. It doesn't. Go ask the GPS people. They don't use it. What happens in physics, big physics, is you have big personalities with big egos who sit around and say, okay, this is the way I see general relativity would have to work, and if it's got to be used, and the adjustments they use in GPS can be explained because with relativity. And that is false. From who says that? Ron Hatch, who has probably close to 40 patents in GPS. He says it to everyone's face. GPS does not support relativity. It shows the flaws in relativity. And it's not a tweaking. A photon is a discrete packet of what? No offense, but of what? What's a discrete packet of? Is it ether? Is it a discrete packet of energy? No, energy is a concept. We know that. It's not real. What is it? Particles? Waves in a particle? Is it discrete? Is it waves through an ether? Are they just particles? Is it a package of what? Basically, I believe the universe is information. Well, it's information, yeah. I mean, we get information, yeah, and we get information in forms of waves. That's how information is transmitted, because it's the only way to transmit information. Random stuff does not give you information. The only way I can send information to you is to send it in waves, just like Morse code. So, yeah, in that sense. So you can shoot neutrinos through the Earth. No, you can shoot something through the Earth, but they're not neutrinos. But again, if you believe in neutrinos, I want you to read Karazani's work. I want you to read his dissection of where it came from. Why don't we have it in the textbooks? Because if they put that in the textbooks, we would have to question the neutrino. And they're not going to do that. I've talked with people who say they're experts in neutrinos. And you know what they say? Oh, Dave, the idea that Pauli came up and applied, first of all, he applied kinetic energy equations to decay, which is stupid. No offense, it's stupid. Oh, you're going to get me on? I wish people listen. Listen to what I'm saying. What happens is you shut it off and just say, let David rage on. Don't listen to what I'm saying. Okay? What is radioactivity? Is radioactivity the what's coming out of something radioactive, which is electrons, which are flying out of this? If this was radioactive, it'd have electrons flying out. Is that from kinetic energy? It is within the system. But kinetic energy is from outside the system. So Pauli is saying that what they were doing is they're applying kinetic energy equations to a system that's self-contained. That was the first question that Karazani asked, which he ended up finding and unraveling where the neutrino came from and why special relativity is wrong. So neutrino people they literally say to me, Dave, that's old. We're beyond that. What does that mean? We've thrown away the history of where it came from. Ignore that, and we worship the neutrino. We say, oh, neutrino, you exist. Yes, the origin, you may be right, but we don't care. You have to capitulate. What's capitulate mean? You have to accept something on blind faith. You have to ignore evidence against it. You have to ignore what was found by a brilliant mind like Karazani about where it came from. You have to ignore that. Or you can say to yourself as a critical thinker, oh, I'm going to take everything into account. And I do. I'm one of those people, believe it or not, when someone says, or even comes to this group and says, hey, I know the neutrinos exist, I'm going to listen. I'm going to say, well, maybe someone came up with something. Even though I've studied for many, many years Karazani's work, and I understand what that is and why that is. And I do believe it's correct. But I'm always open. Maybe it's not. And if you don't have that attitude, you are going to fall into the trap of falling in love with your own vocabulary. You're going to fall in love with your own model. And I've got a whole book on this thing, and it's explaining the universe so well that my dad right now is doing an experiment. If you watched my Facebook page, you saw that my dad came over last weekend and we gave a cheer because we made a prediction with our particle model about resistors. And he's an electrical engineer for 40 years, and yet he thinks we now have a way to measure that. So what do we have? We have a model that will predict something that no electrical engineer has ever predicted. We have just simple resistors and a very, very precise volt machine, and we come up with that's real. Those things, that's great. But we don't go around saying, we're right. It's a model. And it's working well. That's all we can tell you. But we're not married to it. We're the ones who are constantly saying, this something's wrong. It ain't going to work. But that's the problem. That's the problem with the neutrino. That's the problem with our current standard model. Is strings are the best example. Strings are the best example. The people came up with strings in the 1960s and 1970s. They came up with strings, and then they were horrified to find out that people were treating them as real. They were completely and on purpose empirical. They were on purpose to be nothing real. They were talking about one dimension. There's no such thing as things in the universe as one dimension. There's no such thing. And they know it. But people made it up. Now they're writing PhD things. Now you see it on the Discovery Channel. You hear people, Neil deGrasse Tyson, say the only place that it breaks down, where a black hole breaks down, is in the middle, the Big Bang, in the very instant of the Big Bang, in the middle of black holes. Relativity doesn't work, so we have to use strings. Are you crazy? Relativity was invented. We have thousands of scientists who know both special and relativity and general relativity are wrong. We've gone beyond that. We've got better models for everything, and we know those things are wrong. So we can use Newton for that. The dark energy and dark matter is explainable. There's no dark matter. What happens is the funny... Oops, I'm getting out of focus because I'm getting all excited. But dark matter doesn't exist. We can explain it with Newtonian physics. No, we don't explain dark matter. It's not needed. The speed of the stars on the edge of galaxies are explained by one simple fact. We treat galaxies as a uniform gravitational field. It's not. How many people right now, listening to me right now, whether it's recorded or not, will believe that if I shoot a probe toward the center of the galaxy, it's going to take a straight line? Anybody believe that? No. If you do, you're crazy, because we're going to get closer to suns. We're going to get this way. It doesn't take a straight path. Even when we shoot a probe out, it's never taking a straight path ever. So if that's the case, we don't treat our calculations. The mistake is we don't calculate the complex gravitational field of a galaxy, which has arms and it's rotating. When you do, and you do just simple calculations like Cameron Rebisol, go look him up. I can't get to him, unfortunately. Our websites, they're blocking us. It's a conspiracy. I don't believe that. But what's happening? That's what happens. And so what do? We get hung up, and everybody cuts on dark matter. We get hung up on it, and then they explain to us the same way with the two guys. I did a video on this. Go look it up. It's on. The title of my video is called "How Physicists, Mainstream Physicists, Are Discrediting and Disbelieving and Showing Evidence that the evidence for gravitational waves isn't evidence at all. It's just noise." And what do the people do? They come on, just like some people will do here, and they'll come on and they'll say, "Dave, you don't understand it. Let me explain to you why. The reason you don't understand why this is actually detecting gravitational waves is you're not understanding our explanations." We understand your explanations. They're not that hard. The math isn't that hard. What we do understand is that if you are wanting to find these things, you're going to do everything, including pretending that noise, and then when you really look at it from a the two people from Denmark are probably saying, I don't believe gravitational waves. They may believe him, may not believe him. Let me take a look at the data. They took a look at the way the person was doing it, and they took a look at the data, and it says, no, this is not detection. Your explanation, they understand the explanation better than the people. And you know what the people did from mainstream who say that the Nobel Prize, of course, was right, because as soon as they find it, Nobel Prize next year. Why? Because they don't want anybody to argue it away. They spent 2.5 years doing no offense, Mr. Matt Riccio. They spent their time not addressing what the problems were that they were telling about, but trying to say, no, you don't understand. There are not problems there. They didn't even address the problems. If you were in a debate, those people would have lost the debate. The debate club, if you've ever been in a debate club and your argument, I'll tell you, here's an argument against why what you found is gravitational waves. Here's an argument against it. Here's why. And then you're in a debate, right? And you're getting judged in a debate. You're in debate competition. You get up and you say, no, you're wrong. No, just tell you're wrong about being wrong. Let me tell you what's right about it. You would fail. You would lose the debate. Debate is you have a premise. I've detected gravitational waves. Then two physicists from Denmark give a very good explanation of why. No, it's really noise, and here's why. Because of the way you're doing it. You're doing it in a biased way, and this is why it's biased. And their argument back wasn't, okay, let me check. Let's do it again. Let's take a look at it. Let's have an independent person look at this and maybe do it. They didn't do that. They spent the next 2 years on video conferencing, going and flying out there to convince them of their system and their empirical way that they did it. Didn't convince them, because that's not the way to argue. They never addressed the problem. If they did, when they do that, it's very superficial. So what will happen is on the debate stage, they'll say, okay, well, yeah, but you're wrong. Let me tell you why. And they would be graded very poorly. They would lose the debate terribly. They'd lose. They'd probably be disqualified, because the rules of debate is you have to address what your opponent is talking about. You don't just say, no, he's all wrong. Here's why we're right. That's not a debate. All you're doing is digging your heels, telling your argument, and saying, you decide. If someone comes up to me in a particle model and gives us something that really shows something really wrong, I don't go, well, no, let me tell you how it's right. No, I think about it. You know who does that more than anybody? My dad and I. I am still have a hard problem with some of our the biggest problem in our, I'll tell you the biggest problem in our model. How does it one particle stay together if it's got a time scale much faster, much going on, and if it's got its own life cycle? That means a particle at this tiny, tiny, tiny level has to be solvent and good for billions and billions of years. This idea that, atoms stay around for billions of years, I don't have an explanation for that. And ether theory does much better at that. I still don't have an answer to it. Who asked the question? Me! And that's the problem. People dig their heels in. They fall in love with their own thoughts, their own vocabularies, their own empirical world that they've made up or model that they made up, and then they defend it. They don't take criticism and say, yeah, you know what? We did that with rainbows. How white light, when it hits a prism, and it has to be not a rectangular prism. We had to not only use our model that my dad is light are particles that travel together in waves. Why would white light, whatever that is in our model, when it hits the surface of a non-rectangular surface, and just think of it as this giant rectangle in space, enormous, the size of galaxies, and that we as a spaceship are lights, and we're all together, and we fly together in formation, and we are one wave of light. And why would we, when we hit into this lattice, this gravitational lattice, why would we then split up? Why would it split up in different colors? And it only happens when you have a triangle. You have to answer those questions. And we, in our own model, we're so not in love with it, we kept shooting ourselves down. That's the attitude you have to have. And that's what the mainstream of science doesn't have. Let's say that our model would be accepted someday. Don't know. I don't have an ego like, oh, Dave, wow. It's not bringing me money and fame. But say that happens. Well, people are going to start falling in love with it, and they're going to take it and do stuff with it they shouldn't, because they're going to fall in love with it and not criticize it. And it's funny because I interviewed a friend of Einstein's. In my movie, there was a friend of Einstein who I talked, a guy who spent the last years of Einstein going to his house every 2 months. And he said that Einstein was very skeptical of lots of things. He wasn't even understanding his own fame, but he was always questioned. And if you read the German works, and if you know German, which I don't, people like Dr. Edward Dowdy, who reads German super fluently, almost as fluent as English, he doesn't have the certainty that we have when we read textbooks about the people who worship him. Go to his Facebook page. It's one big worship-a-thon, although he's losing almost 1,000 likes a day. He was up to 20 million, and now it's going down because, it's not very relevant because we don't use him. Oh, the universe only works because of relativity, but guess what? We don't use it, so how is it so darn important? Let's see. Hello, I truly believe in your model Skype with me, I'd educate you. Let's see. If you truly believe in your model, Skype with me and I'd educate you. Well, I guess I don't want to be in a education mode. I want to discuss what you think is wrong with it specifically. I don't want to just have you teach me. That's not debate. That's why we don't have an organization that does that. My goal here on this channel is not to teach you about the particle model. I only use it as an example because I believe one of the greatest downfalls of mainstream science is that we don't have models, that nothing is physical. We have no... Look up a quark, for goodness sakes. Go to the web and look up a quark. You want me to show it to you? I'm going to bring up the browser, see if I can get to Wikipedia. Look up the quark. Look at the picture we have of quarks. It's so unphysical, it's sad. If some advanced civilization that has more knowledge about the way the universe works than we do comes and they look at the picture of quarks and even look at the idea of quarks, they're just going to laugh their head off. I'm going to see if we can get to it. I'll show you. So it's not a matter of, it's not educating me. That's what that means is I am all powerful. What I understand, that means everything that we have today is true. Those are great truths. And things like this, quarks, right there. Look at this diagram. Are you going to tell me in this debate, you're going to educate me that picture right there is a picture of what a proton is? Look at that. It's a circle with 3 other circles that are supposedly this quarks. Now, if they're quarks, why do they have so many different properties? There, as Alexander Unziker, who is a doctoral in physics and from Germany, says, quarks are just arbitrary packages with arbitrary attributes. Are they blue? They have a little shiny spot. Do you notice there's a little shiny spot on that? Whoever made this? Does that mean they're 3 dimensions? Well, you can't put the circle around it. That's not a proton. A proton are those 3 things together, right? And then it has gluons. That's what those things are between it. Gluons, they glue things together. Are they little springs? Now, David, these are concepts. Exactly. There's zero physicality here, folks. The people from the 18th and 19th and 20th century that were doing real experiments who would look for things, then try to describe them. We come to the 20th century and Einstein starts this horrific idea that I'm going to invent laws of the universe. It's going to have to follow them. The speed of light has to be measured the same no matter how fast I'm moving in reference to that. And so and then he says all physics is the same in all inertial frames, but then the inertial frames change everything. I'm in an inertial frame where my time is different from yours. What? We have identical clocks. And my slowing down? That's not what he said. He said everything works the same. Then in my inertial frame, well, the laws of what? This is what we have. This is what you're going to teach me. You're going to teach me that this is the way the universe works. That is a picture of a proton from quarks that were invented, never were found first. And then we smash things together, and if you read the Higgs fake, I wonder if I can get to any of these. Oops, I'm not going to. I hate browsing around while people are doing their YouTubes. I refuse to do that. You get when you want to come on. Look at that. When you want to come on, wow, maybe people are coming to my channel that they're going to. This is causing a ruckus. Whoa! Look at all the conversation going on. Einstein didn't invent that concept. Maxwell did. It's so, see, it's not Einstein's fault that it's wrong. It's Maxwell's fault. Here's the link. Okay, I will discuss you. Fair enough. Send the paper, Lapis. The problem is if you send a paper to these people, they're going to educate you not on why you're wrong. What they're going to do is they're going to say this. This is a good analogy that I have. 1 + 1 = 2, right? Well, no, it doesn't if you're using the binary numbering system. Then 1 + 1 is 10 or something, or 1 0, right? Or 1 1 1 0. So they're going to tell you, no, obviously 1 + 1 is 2, and here's why. And then they go in this long explanation about real number system. That's what these people are going to do. And what's going to happen is the people who are stuck, who don't have the ability to take them ourselves and understand that there are no laws in the universe, there are no right models, we only have empirical equations to try to describe way things are moving in this universe so that we can use that to our benefit, and that nothing we ever come up with is right. It's just better than another one. That a model is better than another one. And if you can't come to that kind of conclusion, you are going to defend what is there. You are going to live in this. This is what we call living in the bubble. And it doesn't ever work. I wish our websites were up. Why they're down? Maybe people are doing attacks on it. We do have, the good news is that the website which we have is not only backed up daily on the server, it's also backed up on my computer, and it's also backed up on a backup system. I think it's Carbonite, all those things. We also have a company we pay to look for attacks, and they watch out for it. So if you guys are out there trying to attack and think you're going to bring us down, sorry folks, we are ready. Let's see here. Come on. Science Woke, is that up? Wow. Yeah, I'm going to try this other computer too. I'm sorry, folks. I want to show you stuff. Yes, it's the math. It's just language to describe observations. Always comes first in physics. You're explaining observable reality, not making it up from thin air. Absolutely. Absolutely. And you either have this engineering attitude, which is, I call it engineering attitude. I don't think there's probably a decent engineer that is on the planet that believes in all this mumbo jumbo from big physics and big cosmology. In fact, if you talk to the majority of physicists, if you talk to experimental physicists who aren't the theoretical physicists, when I interviewed for my film for Einstein Wrong, and I talked to a experimental physicist from Stanford Linear Accelerator who unteaches special relativity to his grad students. I said, so what's it like being a theoretical physicist? You just thought I just called his mother the worst name in the world. He says, don't you ever accuse me of being a theoretical physicist. So there's nothing theoretical about physics. These guys who are in the atom smashers, in the particle accelerators, their goal is to let the universe try to tell them what's going on. They're getting really tired. It's so tired, in fact, that you get people like Sabine Hoffenfelder, who leaves particle physics, who leaves the Large Hadron Collider project, because she says everybody's lost in math. She wrote a book, look it up, Lost in Math. Go to Amazon. And here's the thing. people here in this group, which you're totally welcome, and I'm sure they're going to probably leave. You can come here, but there's no use when you don't question or listen to the arguments against what's going in mainstream. This is always happens. The people get caught up in the bubble. They will not see it. You relegate. If you sit there and not look at the criticisms for real, and you don't understand that we who are criticizing often understand your systems better than you do. And it's not because we find tweaks. We're not finding tweaks. It's not that we have to tweak relativity. We've got to throw it out. So it's not small things that we're talking about. And when I first met Dr. Karazani, who showed Einstein special relativity wrong in the early 1940s, while Einstein was still alive, I went to the library at Long Beach Library because they didn't have the internet at the time. It was just right before when the first browsers were coming out in the early 1990s, for the public at least. I had some in the research area. We had them before it came out public, but there wasn't information there the way it is today. I read everything I could about paradigm shifts, like Thomas Kuhn talks about paradigm shift. And there was one thing that was very clear, is that the people who learned mainstream, whatever that was in the time that it was, clung to it, defended to it until they died. And so people who will come here and say, I will debate you, they're not going to debate you. They're going to put you straight. They're going to teach you. Because if they listened to these arguments, they'd find out that they were wrong. And what they look at this is like they're either so convinced, they look in their bubble, that their brain, that model is so ingrained that they can't speak. It's like, I can't understand. It's like, I've got a perfect analogy. Oh man, I really need to keep a book here and write in the same place, because I write it on random pieces of paper, and I got to get a book. I know I have one around here. That's a book where I can write everything. Here's the analogy I just came up with. Chinese, here's what it's like. We have people here that are willing to debate us, right? And that's cool. Here's what it's like. Here's what the debates person, we're saying to them, no, there's another language out there, that the language you are using is wrong. So a person comes up to this person. I guess it's more of the point of view of that person. So I'm a person from mainstream physics. I personally, myself, I took physics. I did very well in physics. I could regurgitate everything about, here's the equations for relativity, calculate the mass difference when you're traveling closer to the speed of light because of this. Here are the equations for general relativity, explain, all those kinds of things. Fine, you can regurgitate anything. But this is what it's like, and this would be a good video. This is what it's like when you're in that bubble of that world and it's falling apart, and you really have to start over, which happens in paradigm shifts. It's like I'm up in teaching, and a person walks up to you in class. You're the professor teaching special relativity, general relativity, neutrinos, the Big Bang, particle physics and the standard model, plate tectonics, not expansion tectonics, but plate tectonics. And a person comes up and talks to you in Chinese. What happens? You're going to start to try to speak in English to them. You're going to try to say, no, chair, book, let's start, book. And then you point to that. You're not going to talk in Chinese. You're not going to get a translator. That's the way people, I believe, psychologically, people who have mainstream science on the brain, that's the way they think. When they see people like myself or other of my subscribers who have super fundamental problems with something like simple space-time, which it's just easy to see. It's not like really hard to understand, but it is hard for a person who has been, that's all they talked about. It's almost like I've learned to do this job and that's what I'm good at. I can't get out of it. That's the way I think now. So when somebody like myself comes up, or Karazani comes up, or Yonel Donu comes up, or Glenn Borker comes up, or Bill Lucas comes up, or Jeff Yee comes up, or any of these people come up, and they talk about, no, look at this. This is a whole new way of looking at the world. We know now what magnetism is. It's actually something. It's not just a field of numbers. Here's what it is. It's as if you went up there and said, oi, tudo bem, pessoal? Eu estou falando outra língua e quem não entende porra nenhuma sobre português não vai entender nada. I just said in Portuguese, for all those who are listening right now, if you don't understand Portuguese, you're not going to understand one goddamn thing. Excuse my language. That's what it sounds like. So when these people come here, they're just like, wait a minute. It's almost like another good example is teaching people with primitive culture, we call it, in the Amazon, for instance. My wife's from Brazil, and there's a tribe which never had contact with the outside. There's probably people living in the jungle who never had contact. It didn't have to be a whole tribe, but regardless. And then you go then and you're going to save them. You're going to, for instance, missionaries. They're going to teach a different religion. Well, why? And their job isn't to say, it's someone comes and the person comes up, well, there's lots of religions in the world, and maybe that comes from people, and that's a necessity people have, and that's cool. I don't criticize, but you're going to have different religions because it comes from people. Well, no, it comes from God. Well, you are going to, if you're a missionary, you're going to say, no, this is right. You don't argue with a person. You don't get in a philosophical discussion of, wait a minute. Yeah, I'm a Buddhist, or I'm a Hindu, or I'm a Christian, or I'm a whatever. And it says this, and there is a problem with that. I've never thought of that. Most people don't do that. And this is not a cut on religion. I have friends who are some of my best scientific friends who are completely different from me in religion. They even believe the earth is much younger. But I like the science that we talk about. But people who are in the mainstream, people who've lived this, who work with those systems, that's like Harry Potter. If you wrote Harry Potter all your life and then you have to write about some other type of magical world that has completely different rules, I'm sure what's her name who wrote Harry Potter is like, it's hard for me because I'm so stuck in the rules I made up for Harry Potter, and they're not going to be interested in learning or saying, hey, that's an illogical rule, here's a better way. So when people hear that, they're in it so much, it's like, this is the truth. The universe only has one truth. It's really hard for people to understand that. Even Thomas Kuhn says that when you get to a part of what we call model revolution, like we are today, we are in model revolution. Read sciencewoke.org, which you can't get to, which isn't launched yet, but those people who are watching this a year from now, go to the site and read about it. We are in model revolution. What does that mean? We can have numerous models that can describe the same universe, and that's where we at. We have at least 4. Ether, particle, lattice, and structural. But wow, I'm attracting people from the mainstream. Global Journal, Science Frontier Research Physics, Space, Volume 2, year, double-blind, peer review, International Research Journal, published, whatever, I'm not sure. The other thing is, too, is if you're published in look, the neutrino doesn't exist. We know why it doesn't exist. We know why it was invented. And then when you take it away, you actually get equations that work. Whereas you have to have magic happen with relativity to have the neutrino work. So the system, even as systems, if you put them side by side and have somebody who knows nothing about them, they're going to choose a simpler system. One without the neutrino and using Karazani's equation is going to win. But saying that you publish in some type of journal or that everyone teaches around the world does not make it truth. If we find out something that no one knew, we rewrite history books. Happens all the time. It's called revisionist history. So having a degree from someplace, what does that mean? Well, our head chief scientist of our group, the John Chappell Natural Philosophy Society, has as its chief scientist Dr. Cynthia Whitney, who has a PhD in physics and relativity from MIT. Now, if someone's going to tell me if that's not a prestigious title from a prestigious place and about relativity, then no one can argue against that. And guess what? She's the one going around saying we have to revisit Einstein. Things aren't right with it. Just because it's taught in a university, or you've been published, or your professors, or every university teaches relativity, guess what? We are now starting to see cracks in that. We have evidence of teachers who will not teach. In my film, go EinsteinWrong.com. Go watch it. The advanced physics teacher says he did not teach the 46 pages of relativity to his students. You know why? Because the students felt it was irrelevant. That's the reality. Yet when you go and brainwash yourself in the universities, you go, oh no, relativity's got to be for everything. We have this idea that there are geniuses out there. And that's what it comes down to. You want to know what the problem is? It's an emotional problem. The problem isn't a scientific one. The people who want to teach us and debate us and show us our errors are people who think they're smarter than us. And the truth is, there's a level of smartness and dumbness, but there's no such super genius of anything. We can have wired brains that can literally pump out music. It's not genius. It's just a brain that's wired. They can't add 5-digit better digits than we. People who have these abilities to tell what day of the week it is on whatever day, they don't do calculations in their heads. They actually have their brain wired so they remember all those things, so they can just look it up like a memory. It just sticks in their brain. We have proof of this. There's no such thing as genius. There is no. Einstein was. He stumbled upon something he thought was great that then convinced other people, and that's great. But he wasn't a greater thinker than Quincy Jones, who is a music genius. We call music genius. He's great. Einstein was a great thinker. Obviously, he influenced people. But he didn't have a super brain. His brain wasn't like supersized and children who graduate from college at 10, they don't turn into, they just get to adulthood faster than we do. We got to get away from this idea that there's these super smart people, that when there are astrophysicists, that there's some super brain that understand the world way better than us. And that's why a perfect example of that is the fame that we have with famous people. You get famous people that we all know are dumber than a doornail. They have zero logic. And because they're famous, they'll come up with something you're looking at them like, why are we listening to this rock star about philosophy or about politics when they just have no clue about what they're saying? So those people who come to us, who I call intellectuals, the way I define it, are people who want to be smart. They want to show that they're smart. I choose to hang out with people who know we're lucky to cobble together any type of empirical equations that will do anything useful, and that we have very little clue about what the universe is really doing. We have lots of empirical equations, and that comes out in the reason that we say that we are going to write unified equations for the universe. We're going to unify the four forces. Well, the four forces came along because we didn't have a model that sort of modeled everything in the first place. That's where we are today. Like it or not, and if you choose to be in the camp that says, I'm going to teach you, we already know mainstream science is right, you are relegating yourself to obscurity. 100 years from now, when one of these models really does make it, and one of these models is really going to be used and will be useful and will make us do things like faster and light communication. Our model shows that this is very possible. And when somebody finally takes the model and actually does that, they go, oh, wow, how'd you use this model? Oh, maybe this model's a good model. Then all you people who are trying to teach us today, who are not in the model revolution, are relegating yourselves to the same people who laughed at Copernicus, the same people who laughed at the people who said there were atomic structures, the same people who laughed at the people who said that there was plate tectonics, whether they're expanding or not. I'm not saying that, but the idea of plate tectonics and that these plates are there and that they fit together. Yeah, plate tectonics, expansion tectonics is a better model. But people laughed at those kinds of things. That the Earth was not the center of the universe. That in the beginning of the 20th century, if you said to somebody that the universe was 13 billion years old, they'd look at you and laugh their head off. Because at that time, it was only millions of years old. Every time we get another telescope, darn, we got to make it bigger. We got to make it older. So if you today are not recognizing that modern physics and modern cosmology are broken, and that's one of the things that shows us they're broken, and it's broken because we invented and with our egos pretended that we found them. We invented quarks and pretended we found them. If you don't believe that, read Higgs Fake. The Higgs Fake. Read the book. And you'll find a physicist from Germany who pulls the curtain on the way they do their process there. It would not stand up to any engineering scrutiny. It'd take an hour for the engineers to just laugh at it and throw the book in their face. Because of the way they do their processes and they find the things. They claim to find stuff. That's where we are. So if you are in that book and you can't see it, you're either saying, I've had people say that. I've actually heard some people say, look, I know this is all wrong, but this is what I've learned, and so I'm just going to keep teaching, and I got to retire and make my money. Okay, that at least is an honest answer. But those who want to save us are relegating yourselves to the Flat Earth Society, to the Earth-centric, the geocentric society, to the everything's made out of earth, wind, and water, and land, and not atomic structure society, those kinds of things. So, quantum entanglement is just an interference phenomenon in a joint information field. Quantum Hilster, the entanglement comes from this is an easy answer. Quantum mechanics entanglement comes from the fact that we have no model for gravity, light, and anything else that we're using. When we take a look at the double slit experiment with a detector using our model, our particle model, for example, everything's explainable. There's no entanglement anywhere. It's absurd. Entanglement's an absurd notion. And if you try to describe it, because it's been around so long that you have to describe it, it's absurd. It's absurd conceptually. There's nothing in the universe, if you believe in a physical universe, that can communicate anything at an instant amount or knows what's happening instantaneously, or even super fast, what they're talking about. They have no clue, so what they are doing is they're basing the entanglement upon something that has no physicality. They're making some philosophical interpretations of it, and they are gone off the deep end. Man, I could keep going here. People keep coming. Distance and time, speed don't exist. They're abstract concepts. Yes, they are. And I have one abstract concept respectively alter whose value. That's the mainstream are claiming quantum teleportation of information. What about that? Oh, you want to know? That's a good question. Again, it has to do with their interpretation of what's happening. It all comes from the double slit. Here, I think the easiest way to explain it to laymen is they start out with one beam of something. They then split that beam, and then they say that now the things are on both sides, and those things know of which is going. No. What's happening is the identical things are happening, or very close to the same things are happening on each side. They're not transporting or teleporting anything. Here's what you do. You would take, okay, Let's use the Hilster and de-Hilster's particle model. Let's take the experiment that they're saying that there's transporting and see if the model can tell us a different story. My guess is that our particle model or an ether model or a lattice model or even a structural model will tell you something different, that it's not transporting anything. So it's the interpretation of some people who are completely in an empirical, non-physical world coming up with, conjectures of why something here. It's almost like saying this. I'm going to send two twins out who have identical brains who are saying the same thing, or two machines, and they're programmed to do the same thing. I'm going to send both of them out, and they're going to say these things. And all we said in the beginning, that was one machine that I sent out. But now that's one machine's in two places. How can that be? But it is true. And those two machines, they know about each other because what's over here is no, they're two different things. You think you're sending one, but you're not. How do we explain that in our model? The electron is not one particle. It's a quanta of particles that are going around that one neutron can hold gravitationally. That's what it is. So when you shoot one electron, you're shooting more than one particle. The same with photons. Photon doesn't exist. Light has frequency. The only way you get frequency is in a plurality of particles. End of story. That's what's going on. Oh, here you are. Do you ever talk? Okay. Whoa! Look at this guy. Oh man, this is really cool. David, do you ever talk about specifics? Yeah, we talk exactly about in our book about the exact all specifics. That's all it is. It's not generalities. You want a specific? Here it is. Okay, what's your name? Punch what? Whoops, wrong page. This is the exact setup of what we think is happening in the particle model with the double slit experiment, which cannot be explained by modern physics right now. So first of all, you're accusing us of saying that I don't talk in specifics. Okay? There's a perfect specific. Not only is this specific, it tells you exactly what light is. It tells you exactly how the experiment's working. It tells you what happens when you turn on the detector. The detector creates a G1 field. That G1 interferes with the G1s going through those slits, and that's why we see what we think, what people interpret as going from particle to wave. That's so specific. It's more specific than mainstream science. What are you talking about? Those are not magic words that you say from your mouth by just saying, David, all your videos are abstract. And that you say that your dad's in particle theory is a joke. What does that mean? You don't understand it. How can you call something a joke? You have no idea what it is. And this is what I'm saying. This is not debate. I mean, if you came to our conference, people would look at you like, what are you, just name calling here? Nah, your theory's wrong. That's what you're saying. That's what this is. You and your dad's particle theory is a joke. No, it's not. In fact, we've got one of a student who has just graduated, who's an experimentalist, and my father doing experiments showing things that were predicted by this model that were never predicted before, and it looks like we can find them. What's joke about that? But the truth is we're not here for people like yourself. You can say, that's exactly what, it's like saying, the earth is the center of the universe. I wish I could take you back to that time. You would be stoned to death, perhaps. Who knows? But what kind of statement is that? Because you ignore experimental. We're answering experiments with this model that no one else can. We're giving physicality to light and to gravity that no one else is. Not just our model. Other models do it. I don't understand. Your words are not magic. Saying that we ignore it, we don't. We're extremely specific. You cannot tell me from the standard model what gravity or light even is physically. It's a particle, it's a wave, it's a packet. They don't know. Gravity, it's a fabric, it's space-time, it's the fabric of space-time, it's the fabric of space, it's quantum foam. We say it's a G1 particle, and it's traveling in all directions, and it causes a pressure difference. That's it. We say light is the same particle, it's just coming to you in waves. That's it. Those average person on the street can understand. There's no joke about that. That's a real solution, a physical solution to the wave-particle duality. Well, how much more specific can you be? We can describe why white light, what it is, and why it turns into a rainbow. That's not described. We only have empirical equations that say it happens, and here are the measurements for it. There's no physical explanation in modern physics for that. Want me to turn to the page and show you that as well? How can people just say those things? It's just immensely incredible, in my opinion. Specifics. We have an exact model, and I can even tell you it's the G2 force gravity, which are random particles at a level below light. Way smaller, way faster, probably at least it's at c² speed. That bends light. That's what's bending light. Gravity doesn't. Gravity at another level bends light, not the G2 level gravity. And we can tell you why it bends it, and we can tell you that the G2 force field caused by particles, it's just gravity, happens only if it's non-triangle, it doesn't happen. We can tell you why. You don't have those explanations even in modern physics. And again, because you ignore experimental results. This is one of the big things I talked about. What's the misnomer about? What are the misconceptions about dissident science? That we ignore experimental? No, we look at them. You ignore them. You guys ignore the fact that light does not bend starlight outside of coronas of the sun. You ignore it. I am telling you right now. What's your name? Punch. I am telling you right now. You are listening to this. This is going in from my mouth into the microphone. It's coming out, going through the internet, through G1 particles or whatever you want to call it, comes out, comes into the air, makes waves, comes into your air, and goes into your brain. You listen to those words. You don't talk about that, do you? Hello? See, you don't talk about that. And that's where everything is coming from. That's why you have a NASA scientist. When he retires, he talks about this stuff. Why is he saying that? Why? And you know what people say? Because he want to be famous. And that reveals the biggest secret of all about you people who don't like the criticism. And you're looking for fame, not for truth. Because the question isn't to us whether or not this NASA scientist is shown something wrong with general relativity, which he has shown fatally. What it really shows is that you guys worry about the fame because you know he's going to be famous. My goodness. Holy cow. I don't know what happened today, but maybe it's because I'm getting gosh, it's 2.5 hours, folks. And I've got the most people here. Why don't I just stay on another day? We'll have 1,000 people here. This is a good one. Here's a good one. G2, G3, G4 particles is fictional gobbledygook. It's fictional gobbledygook because you don't understand infinity. That's your problem. You don't understand Borchert's infinity, which everybody's going to have to understand. No, the G1, G2 particles, A1, A2, A2, 3 particles in ether theories, it's gobbledygook. It's gobbledygook because you don't take the time to understand it. Now, if I were to be like you, what I would say is you're not smart enough to understand it. But I don't believe that. I don't think it has anything to do with being smart. It has to be with an emotional thing. I mean, this is not a scientific argument. G2, G3, G4 particles are fictional gobbledygook. That's not a that. First of all, you have to understand why is there G1, G2, G3? It's because we believe that no force in the universe can have, no particle in the universe can make the whole universe. It'd have to be a magical particle. Here's one particle, it makes up the entire universe. It's the God particle, and everything's made from it. Ooh, be careful, Dave. Oh, gotta be careful. This is a historic one. Everything's made from it, but it's got to organize itself somehow. It's like quarks. Everything's made out of just one particle, the quark. Oh, but there's like 6 of them. Oh, wait a minute, there's 9 of them. No, we went back to 6. So you're saying that our gobbledygook, are you saying that you've looked at infinity and understand infinity? Because if you were in a debate class, you would lose with that argument. Stress energy tensor. Mathematics. It's interesting math. It's nothing physical. That's what. I was funny because when I lent my book to a friend of mine who's an intellectual, who thinks he's smart, and he handed it back to me. He says, I can't even get past the idea that gravity would be a push. And I said, so you believe that space-time is real? And he goes, of course. I said, no, it's just mathematics. We have no idea of physicality, if there even is what it is. He said, no, I said, it's tensor equations. He said, oh, no, but tensor equations, they're real. Wow. Oh, wait a minute. This is fun. Maybe this is like, are you like trolls? You know, for those who don't know what trolling is, it's where people go in like they want to kick their dog. But the thing is, I don't get upset by it because it's not going to change us what we're doing in the progress we're making. You know, it's like why I like Tulsi Gabbard, my personal opinion, for being president, because she's just calm. You can just sit there and talk and just say funny things. But, you know, what can you say? If I understand correctly, light is measured to have the same speed in all frames of references for moving observer for an observer who's standing still. Yeah, well, that's the premise of relativity, and you come up with a lot of paradoxes with that. You have a lot of contradictions, and even in the postulates which we've sort of invented for Einstein himself, which is the postulate of the speed of light is constant, and that Maxwell equations are correct, and that the physics is the same in inertial frames. Well, these are all things that, if you understand the assumptions of special relativity, which you're talking about, those things are assumptions, and those assumptions then have certain conclusions. The problem is the critics of special relativity, which there are thousands of them, have come up with many of the same problems, and that is inertial frames. For instance, Karazani shows that inertial frames don't exist. There is no such thing as an inertial frame. And even if you look at even a body in movement, the body in movement are actually movement. You have things, electrons flying around at speeds that are ridiculously fast inside a body that's moving. So you have what you think is stationary isn't stationary. There's movement everywhere. So when you put an inertial frame on a train, do you put an inertial frame on every atom in it? What do you do? There are so many problems with these types of assumptions that special relativity is blown out of the water in argumentation and debates of what is logical or not in natural philosophy that is trying to figure out what's going on with the universe is because it's got too many internally conflicting problems, that the assumptions, that its own assumptions. Now, of course, you can talk yourself into the what's going on with the conclusions, but then again, you have real problems because the predictions of special relativity and frames come from, you end up saying, okay, well, if that's true, what Einstein's saying, as you get close to the speed of light, mass has to increase. And of course, in particle accelerators, mass doesn't increase. So they invent this thing often. Some of the explanations you get from particle physics is there's something called inertial mass, which increase, but regular mass doesn't, which is, oh my gosh, bizarre as heck. You also get that the energy, well, we don't see it while it's going there, but it ends up in energy, which is, of course, energy is a concept, not for real. Yeah, Ponch, you got it. If you don't see that, then nothing. If you don't see that, then nothing can help you. No, it's that you have to. The way I look at it, Ponch, is that you have to explain away the concept of infinity, the way we see it as infinity. It's not G1. I think what you're simplifying it. G1 particles, we're just listing those. No two particles are the same. We just list them because it's what causes what we see as gravity are very similar particles. When you go down a level, they're going to be similar particles that happen. What levels, where they happen, we can't go down that far and pretend to know what's really going on. What we're saying is that the idea of what we call gravity or things orbiting happens from random particles going in directions. And this happens at many, many levels of the universe. So that's all. The idea of G1, G2, G3, it's not like one particle. You're not understanding the concept of infinity. So what can I say? Read Borchert's book on that. Not just saying it and putting the letters by it and then laughing at it. That's not how you learn. That's not how you learn. That is what I believe that justifies Einstein's relativity. Is this if this is correct and relativity is false, what justifies the constancy of light? It isn't constant, okay? Sandra, the light is not constant. In fact, with GPS, there's really good evidence that it isn't. In fact, in GPS, they do something by adding the light speed to the speed of the satellite. So if you take c plus the speed of the satellite, you've already violated the constancy of light. Sorry, it's over. And then what they do is they say, well, we don't violate it because we added to the speed of the GPS satellite, and then we subtract it on the way back, so it all ends up being c. So please be careful when you say those things. The speed of light is not necessarily constant, and we actually have in GPS what looks like to be evidence that in fact it isn't. Or maybe this is going to be like a place. What I've done is I've tracked it and people say, hey, go to this guy because he's crazy and he talks about these things. Have you guys pushed out everybody we have in here that is... Oh, there it is. There he said it. Mass doesn't increase. The inertial mass increases. So right now, I have, as people watching this, all the people that are here because they're so this is like a waste of time for you and to me, right? You guys are all right and I'm wrong. So that's easy. I'm wrong. So go away. I mean, why be here? That's what's happened. That's why they're still here. And of those of you who are my subscribers that are actually critical thinkers and don't sit there and just turn off their critical brain and just learn what you're taught and saying that's what truth is and don't have the ability to question even your teachers, which is like the number one thing that people who move the universe and come up with new ideas get. If you're watching this right now, I'm like an hour, 2 hours and 30 minutes in, and most of the people that are chatting here, and if you look below, are coming in. I don't know. Maybe I think what you do, the people here on this channel right now are feeling this like what happens in gangs. When I was on a jury for a first-degree murder charge and gangs. One of the psychology people of gangs say, which is very true, that people who are in gangs, like in physics gangs, who all are have believe everything that they're taught and don't think critically about it, that they, when they are together, they are big shots. They're powerful. But you get them alone, and they are not. They're actually the opposite. So yeah, right now we have a gang of people that are feeling their oats. They're, as we say in English, that are feeling very strong. And things saying, let's see, what are we saying here? I'm interested in what you have to say. No, you're not. Absolutely, Matt. You have not shown at all you're interested. What you are interested, here's what you're interested. Here's what you're doing. You have friends who are in physics and you're intellectuals. Your goal is to be smarter than other people, right? That's what you want to be. You really do think you're smart, Matt. That's the difference between you and me. I don't think I'm smart. I think I'm a critical thinker. That I think. But I'm not, smart. What does that mean? I'm bright with that. Yeah, you take IQ tests. Yeah, you can score high. Whoop-de-doo. I scored high. Whoop-de-doo. I don't believe that makes me smart in any way. Critical thinking is the difference. So what you're doing is you come here and you say you're coming here and you say, you're going to. What is it? I'm interested in what you say. You're not interested in what you say. You're interested in showing other people that you can take this guy who's actually growing an audience of critical thinkers, which, believe it or not, Matt, you are in the minority. The majority of physicists, the majority of experimentalists, and the majority of engineers do not buy mainstream physics. They do not buy particle physics and all these particles. They don't buy all this stuff about quantum mechanics and all this stuff about brains, all this stuff about history erasing experiments, all this stuff about entanglement. They don't buy that. You think you're in the majority. You're not. You're in the vocal minority. So, David believes there is such thing as gravitational attraction. It is simply a push model. I think it is called Lesage gravity or something. Lesage was a person that came up with it. But our model has a lot more going on than that, a lot more. Lesage did not have infinity in their models. Now, infinity is a concept. Lapis Malelius, laugh out loud. You are the Friday Nerd Hangout. Maybe. Says Pontius, I dismiss quantum entanglement. In fact, quantum physics is complete. Yep, I believe that too. It's a Kabbalah repackages science. Yep, it is. They claim to have proven photons exist particles with zero volume. Well, somebody here is a critical thinker, that's for sure. It's a Kabbalah. Yep, absolutely. The hell? Isn't that a Jewish mysticism? Yeah, something like that. Here we go. Dave is now down to assumptions and insults. No, it's not. The assumption I'm making is about the human nature. It's not about the physics. I am assuming that people who are not critical thinkers are emotionally attached to what they are doing. And you have psychologists who show this. It's called, what is it called? It's one of those things that you're going to prove or believe or find conclusions to the things that you are seeking the conclusion for. It's a technical term I'm not remembering right now. That's what I am telling about you. I'm not putting you down. What I'm saying is that your most important thing is to be smart, to appear smart, not to be a critical thinker. That's what I'm saying. Yeah, that I'm accusing you guys of. Yeah, absolutely. Are you smart? I think so. Are you critical thinkers? No. Because critical thinkers will say one thing, and that is no theory is correct. No law is a law. We do our best to try to do our best with what we have. But there's nothing written in stone. There's no theory that can't be disproven. In fact, everything that we come up with has a counter argument, and we have to just try to keep making better articles. Oh yeah, that's another thing is the Jewish, thing. Lapi, what's in the middle of the atomic symbol where the three eclipses cross? The star. Nah. Do you believe in Maxwell's equations? Maxwell's equations are empirical equations describing something they had no idea what it is. So in the end, Maxwell's equations, in its physicality, there are a lot of problems with. In fact, if you read Dr. Dominus Spencer and some other people who worked in very closely at Maxwell equations, there are problems with Maxwell's equations. Absolutely, Maxwell's equations have a lot of problems. So. Do they do a good job with some things? Yeah. Do they describe, they use fields, which they have no physical description of it. That's why I believe Yunel Deneu's experiments, underwater experiments, are really great, and why I subscribe to them. And so that answers the question. Maxwell's equations, they're useful to a certain point, but there's a lot of problems with them. Absolutely. And I know a lot of people who have done a lot of great work on it. Dr. Emily Eberly Spencer, she worked with her husband, can't remember his first name, but Moon was his last name. She has a PhD in mathematics from MIT. I did. I said Maxwell equation. Okay. First of all, a couple of things. Matt Rico. Okay, I'm a dummy. Laugh, David. I don't know what I'm doing. I'm just intensely interested in science. I'm not sure I really believe you. I think maybe you're sort of like the politicians here in the United States who say they're progressive and they say everything that Bernie Sanders says, but they don't mean the things. I'm not sure you mean that. And first of all, I don't believe in any theory. What I think is theories or models or equations work well or don't work well, or problematic or not problematic. Maxwell's equations, like I said, for a while were very interesting and shed a lot of light on things. But are they problematic? Yes. That comes from people who I've seen talks on, I've read papers about. Do I remember exactly what those things are? No. In my movie, I have 2 objections from Dr. Eberly Spencer, again, who has a doctoral degree in mathematics from MIT, and she says that the problem with Maxwell's equations is that they are wrong. That means there are problems with it, and there are fixes you can use in Maxwell's equations to correct those problems. So that's my answer. Is that my specialty? No. Yeah, I mean, if you Lapis, again, it comes down to models of the universe. We have a particle model, and we have a particle model for electricity, magnetism, gravity, light. They're all real physical things. Moving mass creates the force on everything. It's all Newtonian. Even in electrodynamics, all these things we can describe the same behavior. We can describe what's happening, and that's one model. There are ether models that can describe many of the same things. So, okay, guys, look up Lesage gravity, fast rarefied particles instead of dense fluid, also called Mach gravity. They say thermodynamic gravity. Unified electromagnetism. He unified. That's another thing, is unifying forces of nature is really a straw man. That is a problem set up to be knocked down. That really is not a problem. The universe doesn't have 4 forces that need to be unified. What we have is a universe that is working out there that we need to put physicality to, and all those things will be explainable by a better model. There's nothing to unify. Let's see. I wish the world were Newtonian. Well, guess what? We have at least 3 or 4 very good models, much better than mainstream models today, in my opinion, because they describe things and give physicality to things. They're completely Newtonian. So when you say, I wish the world were Newtonian, we have models that can describe everything Newtonian. And the people who say no because of Coulomb's law, we will say no. Coulomb's law is just Newtonian. You just don't have a model for it. We do. I can diminish push gravity on empirical grounds. So it does not work. What do you mean? You can just say that, but here's the thing. Let me tell you something, Punch. Here's the problem. Let me tell you, Punch. Here's the problem with what you say. In a debate class, you would lose, and now let me tell you why. I'm going to just try to help you here. You can have several models that are very different to describe the exact same thing, and both can describe it very well, and both could even make very good predictions, and even make the same predictions. So do not paint yourself into that corner. You are wrong about that, because you can have, just the same way, we can have hundreds of human languages that can basically say the same thing. I can describe a scene in English and you describe a scene in another language, and we can describe that to this person and they will get the same picture in their mind. Uh-oh, what's that mean? It means that our pushing gravity can work better, or at least as well as mainstream and any other model. What you're trying to do is you're trying to say this model's better. Right now, we can't say that. If you are a really astute person who really looks at all the models that are out there, you realize we are in model revolution right now, that the data that we can have computer programs, human languages that can deal with the same stuff in a different way and still come up with something good. Then you're not going to say things like, oh, I've proved this model wrong. You know what's going to here's what's going to happen, Punch. Let's just say this in the future. Let's just say, okay? And believe me, I'm the last to say this, but let's say that the particle model becomes useful and people start using it, they start teaching it. Then what are you going to say? Then you can come up with something better? Fine. That's fine. But the problem exists in your attitude that this is wrong, and you then just totally dismiss it. If you have that attitude, you're never going to be a critical thinker at the highest level you can be. It's not going to happen, because critical thinkers are going to do what Aristotle said, and Aristotle says it's the most brilliant minds, or the best critical thinkers, are those who can entertain any idea without believing it. And you're not doing that. You're not entertaining it. We have a book that describes things that even mainstream can't describe. The double slit with the detector. Do you have a model, Punch, that describes that? So if you go out and just say, I've proven that wrong. No, what you can say is that model's pretty bad. And here's why. Well, tell us why. Tell us why. Tell me why. Write a paper, send it into our proceedings. We've got a proceedings. Look, we have proceedings for us. Here's some proceedings 1 year. Look at all those papers. Woohoo! Send it in. Show us we're wrong. We'll be very happy. I invite you to make a video or write something and show us how we are wrong. I will actually entertain it. And I'm honest. I'm not saying I'm going to show you wrong about that. No! That's the difference between you and me, Punch. If you really have something, bring it to me. All I hear from people is, "Oh, I've proven this wrong," or and I go, and then when I ask from them, they go, oh, "Here it is," and I go, "Well, I don't get that." It's not, and I'm not going to repeat to you, "Oh, here's why it's right." No, our model is one model. David is a Leonardo of our times. I don't know what that means. Even if you, here we go. Oh, this is good. Here's a good one. Even if you are an applied math major, you still have to. This is. It's just, don't you see you're just repeating the same arguments? I think the good thing is that people on this channel who are real true critical thinkers, they're going to get something out of these arguments because you hear all this stuff and they don't know what to say back to you people. I do. I've heard it all. I mean, this is what you still have to take it out. This is the same thing. Oh, little boy, you've got a degree in math, or you got your degree from MIT in physics. That's a prestigious place. But you don't know this though. That's your problem. You know what's cool? What's really great about the world we live in? I'm not going to be murdered for my thoughts. You aren't going to be murdered for your thoughts scientifically. And time will tell. If you don't have a critical attitude and you're not we're the first ones. It took us 3 years to try to figure out with our own model how light turns into a rainbow. 3 years, we got it wrong. We literally wrote the part of our book 3 times. We're the ones doing it. That's the right attitude. And we're going to say, this is just a model. It can be completely wrong. But you know what's funny? Every time I get a book from somebody, and I get a lot of books from people, because they know that I'll actually take the time to read it and try to figure out what's going on, I look at it and go, maybe this guy found it. This is it. Maybe the guy found it. I look at everything that way. I'm like this child that's like, every time something else comes, even somebody's new theory that seems crazy to you, I'll look at it and say, what does this person spend time making this theory? Wonder what they're trying to say. Is this cool or what? Jeff Yee, I think that the particle model is better than an ether model. I love his model though. I think it's great. How can you do that, Dave? It's the same way that I think Portuguese is a beautiful language. But I speak English. People got to get that more attitude. It's like finally here in the United States, we're starting to realize Christianity is not the only religion. And we're not, it's sort of funny. When I grew up, Jewish people were okay, but Hindus, forget them. Oh, Muslim, forget them. No, it's like, hey, everybody has their religion. That's cool. Everybody has their language and their culture. That's cool. You have the way you look at it. That's cool. No, what people are coming here because they're afraid. The only reason people come and try to set me in my ways is because they're afraid what they know is wrong. Oh no, I know it's right. No. If you do, why do you worry about it? If there's a person going on the street, do you go walk up to people who think the earth's flat and try to convince them? I don't. Let them think that. What do I care? Dichotomy minded, because people are team minded. Yeah, Mr. Grimm, absolutely. It's called groupthink. And especially when they get together. Let's say right now I have a bunch of friends who are like physics students somewhere, and they're all intellectuals thinking they're going to go back to their class reunions and tell everybody they're astrophysicists from MIT and Caltech and Stanford and Einstein Institute in Germany, or from Oxford or from Cambridge or wherever. And they're coming here because they want to reinforce each other. They want to show that this Dave is nuts. This whole movement, the reason he's growing pretty well, his subscribers, isn't because maybe what he's saying has some merit. We're just going to go there and we're going to make sure that our group, we're getting our degrees in, and we're going to make our livelihoods at trying to find black holes, even though the black holes that we describe probably have a lot of problems, and maybe they're not really black holes but just very dense objects. But whatever, we got to come here and make ourselves feel good that our group is the right group. That's why you're here. The flat Earth. Well, for those of you who don't know, the flat Earth is run by a lot of people who are pulling your legs. They know the Earth's not flat. They're just trying to see how far they can go. And it's so funny. It's the same way. I'm not doing this this is different between me and the flat earthers. I'm not doing this to pull your leg. I'm doing this because of critical thinkers I've been hanging out with since I was small, and in thinking about science. There were so many problems with mainstream, the model that didn't make sense. And then when I started hanging out with critical thinkers, I started finding out what those problems were. We started fixing those problems, and we're on to better models. That's where we are. That's why I'm doing it. I'm not doing this to pull someone's leg or to be Believe me, I'm not doing this to be popular. So, my goodness, this has come up to 3 hours. I'm going to stop. But I think let's chill with this movement is growing. Speaking of black holes, are we sure that they are very dense? Well, we know they're pretty dense, and the reason we know is from Sagittarius B, and that if you look at the center, if you can see my movie, EinsteinWrong.com, yes, I charge $3 for it. That's to keep it up there, and for the investors, I keep it there to be instead of just throwing it on the internet. It's there. It pays it for itself to be on demand, and so that people can watch it in Vimeo. Anyways, if you go there, you'll see Sagittarius A while I'm talking to the NASA scientist who says, yes, we know there's a very dense object that is not emitting light. It's not that it doesn't it eats light. It's just that we don't have any light either reflecting or emitting from it, but it is very dense. It has to be because of the star sizes that are ripping around the core of the it is definitely non-luminous, and it is very dense, because we can sort of calculate its mass, and mass meaning in the gravitational mass. So okay, Sandra, I will it's called a singularity. No, Matt, singularities don't exist. Singularities is a mathematical construct that's impossibility. It's an infinite point with infinite mass, and even Neil deGrasse Tyson, and even Stephen Hawking before he died said, that's the singularities are possible. Okay, so you want to know what what happened? I thought I saw a question about G2. Oh, she retracted it. I'm not sure. What's that mean? Well, Sandra, you were asking about the G2 particle, but I doubt if maybe you were just pulling my leg. I don't know. G2 is very simple. It's what it is we just call it that because we know there has to be something there. You can't have light curve. You can't have electrons go around a nucleus without some force. We believe that all forces have to be real physical actions, kinetic actions. So we know that there's going to be particles and a gravitational force. That's what makes things orbit. G2 force, if you were to translate what that is, would be the strong nuclear force. It also that's why magnets, when you have very strong magnets, they just make our regular gravity, G1 gravity, look like nothing. Is because the things that are pushing together magnets are the same force in our model as the G2. So our model sort of says to us that what people call the strong nuclear force is the same as what brings masses together in magnetic force. So if you want to call it anything, it would be what causes that. Well, listen, I'm going to get going. I think that's plenty. I really appreciate everybody sticking around, even if you're having fun. I think it's good for people who are critical thinkers, because when people come up with the standard things that I'm going to teach you, or arguments that your ideas are stupid, or this has been proven, or whatever. We do have answers to those things. We understand when it's just an emotional thing. We know all those things. So thank you so much. I greatly appreciate it. I'm David D. Hilster. Remember, I say, stay critical, stay thinking. I am your science therapist. I'm going to try to get you to the become science woke. Ciao for now.